Hello everyone and welcome to the video course Master Python for Data Handling. In this course you will learn to master Python's native building blocks and powerful object-oriented programming with the intention of making you able to use Python for data science and machine learning data handling tasks. My name is Henrik Johansson and I am the instructor for this course. In the next minutes you will be informed about what you will learn, the intended target audience, expected workload, course requirements, a short instructor introduction, and some information about Udemy's grading system. So now we'll talk about what you will learn. And this course is about learning you to master the Python programming language with the perspective of data handling. The short story about technical data handling is that data handling is about moving and transforming data to usable forms and structures. Data scientists and machine learners spend about 80% of their working efforts and time on data handling tasks. Being good at data handling and Python programming are extremely useful and time-saving skills. The Python language you will learn in this course is Python's native building blocks plus Python's advanced object-oriented parts. You will learn to use and design your own advanced constructions of these building blocks and to execute detailed data handling tasks using Python's native building blocks and with limited assistance from file handling libraries and Matplotlib. You will learn to use Python's data types, native data structures, data transformers, functions, object orientation, and logic. You will learn to make your own custom functions, custom objects, how to move data around between common file formats, and data structures. You will learn to use advanced multidimensional uneven data structures to manipulate data and to generalize functions. Compared to university courses in computer engineering or system sciences, this course will propel you to about the general 1 year of studies level with respect to programming and to the general master or research level with respect to data handling. This course is an excellent entrance to learning the Python language, and in practice this course is the course we ourselves would want to be able to enroll in if we could time travel and re-enter the university as new students. In our opinion, this course is the best course to learn the Python programming language and to learn data handling. For this course, Henrik Johansson will be your instructor. Henrik has a broad instructor and leadership experience with more than 20 years in roles ranging from university teacher within the most mathematically advanced courses in data mining and statistics, to sports coach and leadership roles in the private and public sectors. Henrik has experience teaching students from all walks of life, from the poor to the royalty, and has taught students from nearly all educational backgrounds, from high school students to doctors. So who are you, the intended audience for this video course? This course is an excellent choice for anyone who is new to programming. You will get the best possible start as a programmer. And this course is also excellent for anyone who knows programming and wants to learn the Python programming language. You will get the best and most complete Python course available. And this course is also excellent for anyone who is a new student at university level and want to learn skills that they will have use for during their entire engineering or academic career, as well as in all university courses, jobs, or theses related to data science. And this course is also excellent for anyone who knows Python and want to extend your knowledge of using Python into the data handling domain. You will get the best course for anyone learning to use Python for data handling. And this course is also excellent for anyone who wants to reach the intermediate level of Python programming knowledge as required by many Udemy Python machine learning and data science courses. You will get a course that teaches you the knowledge to fulfill the intermediate skill requirements in Python for these advanced courses. So what is the expected workload for this course and time requirements? And we can say that while listening to all the course materials is an exciting 8 to 10 hours endeavor, the main exercise for the course is to replicate the code, and this may take twice or 3 times the time to listen to the course. The total workload for the course is less than 10 to 40 hours, depending on your decision to replicate the code, listen to the entire course, or to cherry pick from the content useful to you. And we can say that if you have some knowledge about Python, this video course will be very easy for you. And this course will quickly and easily propel you to the intermediate Python level. If you know another programming language, this course will be a very easy road to learn the Python programming language. And this course is able to take you to the intermediate Python level with some effort. If you have no programming experience, this course will require some effort from you. And if you don't have any prior programming knowledge or have some experience with tabular software or Office packages, this video course will give you an excellent start as a Python programmer focused on data handling tasks, or an excellent start as a data scientist or data analyst using Python to manipulate data to fit your particular program or libraries. And learning the content of this course will propel you to the intermediate level, so you fulfill the requirements for many advanced Python and data science courses on Udemy. And the course requirements for this course are quite humble. So this course assumes that you have everyday user experience with operating systems such as Windows, Mac, or Linux. And if you are able to enroll in this video course with your web browser, you likely fulfill this requirement. And we will also say that the new Anaconda Cloud Notebook is advertised by Anaconda to make Android and iOS operating system users able to use the Jupyter Notebook through their web browsers. And this means that Android, Chrome, and iOS users also should be able to follow the course in its entirety as advertised. And we must also say that this course is given globally, and the requirement for the 4 ways of counting establishes basic schooling. So literally most people should fulfill these course requirements. So now we'll talk about the Udemy grading system. And a short time after you have enrolled in this video course, you will receive messages from Udemy asking you to grade this course. And our intention with this course is that it shall be the best from basic to intermediate Python programming and data handling course on Udemy. And we aim for high quality mass dissemination, perhaps 100,000 to 2 million or more students within 5 to 10 years. And if you rate this course with 5 stars, it will motivate us to update this course for your benefit. And this increases the course's merit value without any other effort than rating this course 5 stars. And rating this course with 5 stars will signal the high quality of the course and increase the curriculum vitae value for your CV when you acquire the Udemy course certificate at the completion of this course. And before you grade the course, feel free to ask questions if you wonder about something. Alright, now it is time to continue to the installation and setup procedures for Anaconda Cloud Notebook, and or optionally to download and install the entire Anaconda distribution or any other Python capable system of your choice. And we look forward to see you in the next video. Hello and welcome to this video. We're excited to have you here, and in this video you will learn to start and register for the Anaconda Cloud Notebook to be able to directly start with the video course main materials in less than 1 to 3 minutes from starting your web browser. Having a Gmail address, a Microsoft account or a GitHub account is even faster and may make the starting of the Anaconda Notebook into a one-click event after registration with a verification code sent to your Gmail address or account address. The Anaconda Cloud Notebook is a Jupyter notebook with a large but limited set of libraries, which is able to handle all parts of this video course. The free accounts are public and not private, and also limited in storage and high compute minutes per day. Now we'll show some screens from the registration process and some basic input into the Anaconda Cloud Notebook so you can begin with the video course as simple and fast as possible. So let's start up your web browsers. Alright, having started our web browsers, we use Bing or Google search engines and search for Anaconda distribution. We push enter and follow the link that the search engine gives us. And we arrive at Anaconda Distribution's download page. And here we click the code in the Cloud button, and we arrive at Anaconda Cloud Notebooks page. And we push Get Started for free. If you don't get the sign up option automatically, push the sign up button to trigger a sign up option. And push Create Free Account. If you have an active Google account, you can sign in directly with the Google account. Or you can use the sign up button below to trigger a general sign up option. So let's do that. And we enter our email address. And we enter a password to our Anaconda Cloud account. And we push Sign Up. And we are required to use a verification code sent to our mail address. So we copy and paste it. And push the Submit button. And here we have the option to register to get more content. And for this demonstration only, we just click that option away. And here we have lots and lots of materials intended to teach you how to use the Anaconda Cloud Notebook. Some of these are great, but now we're going to activate our Jupyter Notebook. So we click Notebooks at the top of the screen. And this launches Jupyter Notebook in Anaconda's cloud as a server. And here we have the skin of the Jupyter Notebook. and at the top we can see our available compute time, our data storage, the number of used kernels, and now it is time to start coding, and in this video we select the Python 3.9 kernel for our Jupyter notebook. And in this condition or state, the Jupyter notebook is ready for use, so let's type some code to show how it works. And we type print hello world and welcome to the course. And we run the code with this button, and the machine type hello world and welcome to the course. And as you can see, a few compute seconds were consumed by this operation. And here is a button that can be used to save your code. And there are lots and lots of options for using Anaconda's Jupyter Cloud Notebook around. And you may feel free to explore these options, and you are now able to begin the video course. So let's print. We look forward to see you in the next video. And we run this code, and the machine prints. We look forward to see you in the next video. Hello and welcome to this video. We're excited to have you here, and in this video you will learn how to download and install the Anaconda distribution and how to start Jupyter Notebook from Anaconda's navigator. The Anaconda distribution is a free Python distribution for programming, data handling, data analysis, and computing. The Anaconda distribution is considered to be one of the best options for data science and machine learning. The Anaconda distribution contains many useful tools such as JupyterLab's Notebook and the useful library or package managers Conda and pip. JupyterLab's Notebook will be the main tool for teaching Python in this video course, and it is accessible from the Anaconda Navigator, which is a graphical user interface included in the Anaconda distribution. The Anaconda distribution provides you with a very solid, mainly open source development environment for any currently sold Windows, Mac or Linux machine. The Anaconda distribution can also be further augmented with commercial level environments such as Visual Studio Code. The Anaconda distribution provides the broadest possibilities with the ability to choose between a large number of environments, including the excellent JupyterLab's Notebook, the Conda or the pip package managers. A major bonus with Anaconda is that it is one of the biggest cookie cake collections of code available. The caveat is that the current development speed creates a regular pattern of updates and emergency bug fixes, and sometimes a need for augmented package managers when an installation becomes complex over time. Consequently, the Anaconda distribution's environment is developing, and the graphics of web pages accessed in this video may change or appear slightly different than in this video. And this is important to remember in this installation video. So, some of you may already be expert users of Python or some of the tools that we will use in this video course. If you are one of these persons and you have your working environment in order, you may skip this video and continue with the next video. Now we'll download the Anaconda distribution, and to download it we need to start our web browser or use a search engine, for example Google's search engine or Bing or any other search engine. So start up your web browsers. Alright, having started our web browsers, we can use, for example, Google or Bing's search engine and seek the Anaconda distribution and follow the link that Google presents. So we type Anaconda distribution and push enter, and Google or Bing will return a list of links to the Anaconda distribution's download page. And we push the link, and we are sent and arrives at the Anaconda distribution's download page, which currently looks like this. And Anaconda distribution's download page is easy to navigate, so if you are using Windows 10 or 11 64-bit, you download using the currently green download button with the Microsoft sign here. And if you want to use the Anaconda Cloud Notebook, you use the cloud symbol or code in the cloud here. And we can open it in a new tab and take a look at the entrance. And it currently looks like this. And you will need to create an account, and when you have created an account you will receive storage space, compute seconds per day, and installed libraries for free. So now we'll close the new tab for Anaconda Notebook and return to the download page. And we will tell you what to do if you don't have a Windows 64-bit computer, for example if you have a Linux or Macintosh. And if you want to use Linux or Macintosh, you have to look for your installer around Get Additional Installers option. Around here. And we can open this option in a new tab and take a look at it. And it currently looks like this. So here you have installers for Windows 64-bit. You have installers for Macintosh and for Linux. And if you can't find a proper download package for your particular computer, you will have to visit this link. For example, if you have a Windows 32-bit machine, an old computer, a Linux special distribution, or if you have a PowerPC machine. And then you can look at this additional page with installation instructions here. And you can go down here in your lists and look for your particular system. So now we will return to the Anaconda download page. And now we will download and install our tools and working environment, and Anaconda makes this easy with a gigabyte-sized installer and currently requires about 5 to 6 gigabytes of hard drive space when installed. After installing the Anaconda distribution, its Conda Package Manager can be used to download and install more Python libraries and packages. And the total size of the installation can easily reach 10 to 30 gigabytes of hard drive space after about half a year's use. So this is important to think about. Anaconda installations tend to grow in size over time. And for this video course we are going to install the latest version of Python for this video course, and Anaconda distribution includes this version and makes the installation procedure straightforward to follow. And we will walk you through the entire installation procedure on Windows 11 using Anaconda distribution's installer. So we push the green button to download the Anaconda distribution like this, and the downloads has started. And we will speed up and fast forward this process so you don't have to watch the download meter. And depending on your download speed and the available bandwidth at Anaconda, this may take a short time or a bit longer time. And when the download is complete, we run the installation file, for example by double-clicking it to start the installation procedure. And we are presented with a welcome message to the Anaconda Distribution's installation guide, which is an easy to follow guide. So let's follow the guide and push next. And we are presented with a license contract, which I suggest you read before you sign it. And when you accept the contract, you push the I agree button to continue the installation. And in the next step, you will decide if you will allow anyone who uses your computer to use Anaconda or if you will limit the use to yourself, which is recommended. And I suggest we follow the recommendations. I really suggest we do that. And we push next to continue the installation. And here we have the option to select the installation folder, and I strongly advise that you use the pre-selected destination folder. And here we can also see the space requirements for the installation, and pushing the next button continues the installation. So let's push the next button. And here we have dangerous advanced options, and I strongly advise that you don't make any changes to the installation screen in order to minimize the risk of potential problems with the Python environment's different parts and paths. And I recommend to just push the install button with the pre-selected values and to only install the Anaconda with the pre-selected options. So let's push the install button. And this will take some time, and we will fast forward and speed up this part of the installation procedure until the next step of the installation procedure. Alright, having completed this part of the installation procedure, we can now push the next button to continue to proceed. So let's push the next button. And we push next to continue. And we will not launch Anaconda Navigator right now, and we will not start getting started with Anaconda distribution. So we push finish. And now we have completed the installation of the Anaconda distribution. Alright, now we're going to start the Anaconda Navigator. And on Windows machines, the Anaconda Navigator is started from the Start menu. So we start the Start menu, and here we can find Anaconda 64-bit. And we can start Anaconda Navigator. Like this. And starting up Anaconda Navigator can take some time on some machines. So we will speed up this loading of Anaconda Navigator a bit. And this video is recorded on a near 10 to 15-year-old computer. And here we can see Anaconda Navigator. And the first thing we see is that we get an invitation to start the Anaconda Cloud notebook. And for this video we will start the Jupyter Labs notebook, so we will just push the cross to remove the invitation. And here we can see the Jupyter Labs notebook. And to start it, we just push the launch button. And the Jupyter Labs notebook will start inside a web browser. Like this. And the first thing we will do is that we will use the new button here, and we will start a new Python 3 IPy kernel. And this will start the Jupyter Labs notebook in such a way that we can enter code into it and run code inside it. Like this. And here we can see that the kernel is starting. And we are ready. And we can test that the Jupyter Labs notebook functions. So we can type print hello world and welcome to the course. And we can run this code by pushing the run button. And the machine responded by printing hello world and welcome to the course. Alright, now we have downloaded and installed the Anaconda distribution, and we have shown you how to start the Jupyter notebook from the Anaconda distribution. And if you wish to delve deeper in the Anaconda distribution and the Conda management systems and some other details, you are welcome to do so. We have an extra course with some theory about the Conda management systems, which is used by the Anaconda distribution and which Jupyter Labs notebook is dependent on. So if you want to learn how to create environments, how to install and uninstall libraries and their versions, that optional part of the course is now a good place to go. Otherwise, if you just want to start with the course, the next non-optional video is where you are heading. And we look forward to see you in the next video. Hello and welcome to this video. We're excited to have you here. In this video you will learn some useful things about Anaconda's Conda management system and to use command line terminals to update, downgrade, upgrade, download and install Python libraries and to create environments. We will describe Conda and teach you some useful Conda instructions, talk some about Conda environments and package managers. Before we start the Anaconda Navigator and an included suitable command line terminal, we will talk some about the Conda package management system. We will begin to talk about Conda, which would be the central piece of this video lecture. All code we use in Python are organized into programs, packages, modules, and libraries and native code, which is code for platforms. And the Conda package manager keeps tracks of the dependencies between packages and platforms. The Conda package format is identical across platforms and operating systems. So what is a Conda package? A Conda package is a tarball file or Conda file with system-level libraries, Python or other modules, executable programs and other components, metadata under the info directory, and it can be a collection of files that are installed directly into an install prefix. And this means that a Conda package is a very general definition. Now we're going to look at some useful instructions that you likely will need sooner or later when starting to work with Python and data handling. And we'll begin with Conda search Conda, and the search command gives you a list of all available packages for this library in your list of accessible channels, which usually is the default list. We can type Conda search SciPy, and this will give you a list of all available versions of the library SciPy. We can type Conda update all, and this command updates all available libraries. And all libraries may also means Conda, Anaconda, and this is also useful, but may also, depending on your active channel, introduce many new dependencies. A very useful instruction is the instruction to change versions between specified versions of libraries. So we can type Conda install SciPy equals 1.9.3 and respectively Conda install SciPy equals 1.11.1. So the first command will downgrade SciPy to version 1.9.3 and the second will upgrade SciPy into version 1.11.1. And this is one effective way to change different versions of a package. Just remember that the Conda package manager attempts to resolve all dependencies when changing library versions. And now we will teach you how to change between two Conda solvers, something that becomes more useful for speed purposes the more complex a Conda installation becomes. For the first installation of libraries after this video course, the classic solver should provide sufficient speed, but remember libmamba for future use and future complex installations. So if you want to use the classic solver, you can type conda config set solver classic, and if you want to use the libmamba solver, you type conda config set solver libmamba. And this solver tech is considered very advanced, and the alleged main difference between the solvers is that the classic one is coded in Python and allegedly runs on a single CPU, single thread basis as a standard, whereas the other is coded in faster static languages. Both solvers are used and sanctioned by Conda and should be able to solve the Conda equations. Now we'll show you some ways to clean a broken or encumbered Conda environment. You can download the Anaconda Clean program and run it to clean Anaconda. So you type conda install Anaconda Clean. And then you type Anaconda Clean, and after using it you should reinstall all your libraries. Another way is to use the conda clean all command to clean out old libraries. And a third way is to use the conda install revision 1 to return Anaconda distribution to its state directly after the first installation. So now we'll show some instructions which provides useful conda information. And we will begin with conda info, which will show you the current conda background info, and this is often very important information. And you can type conda list, which will show you all currently installed libraries or packages, and this list is often long, but shows all installed packages, versions, and all such things. And this may be very useful to you one day. And you can type conda list environment to show you a list of all environments and mark the active one with a star. And this instruction is absolutely necessary when and if you are working with multiple environments. So now we'll show you how to create a new environment. And environments are useful as they protect and isolate the base installation from problems and to some degree prevent damages from causing reinstallation needs for the entire Anaconda distribution, as well as allow other package management systems such as pip to be used effectively with the Anaconda distribution. So we will create the environment DSML environment using Conda's base channel for its creation, and we will add some common libraries as well as the Jupyter notebook to the environment. So you can type conda create N for name, DSML environment, Python, IPyKernel, Jupyter Notebook, Pandas, NumPy, SciPy, Seaborn, Scikit-learn, Stats Models, and Matplotlib. And in this case we install Anaconda's latest stable versions of Python, Pandas, NumPy, and other libraries. And we also install IPyKernel, Jupyter, and Notebook, and these are necessary to use Jupyter Labs Notebook with your environment. And below here we also show the same code for a more experimental Conda Forge channel, which inter alia will create an environment with Jupyter Notebook 7 and other recently modified libraries in development. And the advantage of using an environment is security, reliability, and the ability to quickly recover from coding disasters. And the main disadvantage is a higher degree of complexity plus a need for coding competence, which is shown at a fundamental level in this installation. And the current simplest and lowest effort solution is to use Anaconda Cloud Notebook. And when you install on the base or root environment, the code and all actions become simpler, but the risks for a problematic or hard to recover environment grows with the number of installed libraries or programs. And for this course, using the base environment should not pose a problem. But traversing of the grand cookie table of other programmers' code, for example at GitHub, may entice you to install many programs from different coders, different maintenance levels, and different coding practices, and the number of installed programs and libraries may quickly grow, as well as the number of environment issues. Now we'll talk about the two package management systems Conda and pip. And we will repeat and extend some facts, and you will learn about the two main package management systems and installation methods available to the users of the Anaconda distribution. And the preferred package management and installation method for this video course is the Conda management systems installer Conda, and secondarily, if a wanted package or library is not available for Conda, the Python authority's pip installer or pip. And the Conda package management system or Conda installer is a cross-platform environment manager that installs, updates, and keeps tracks of the dependencies between packages and libraries. And Conda mainly installs libraries and packages from the Anaconda repository or the Anaconda cloud. And Conda packages are binaries not limited to Python code, and you don't need a compiler to install these packages, and this can be very advantageous. Pip, on the other hand, is the Python packaging authority's package installer for Python. And pip installs Python packages software as wheels or source distributions, and this may require the installation of compilers and additional code libraries before installation. And when using the Anaconda distribution, first use the Conda installer, and if the package is not available in Conda, use the pip installer. And it is necessary to state that Conda and other management systems seldom are compatible with each other, and when used together may cause issues or broken libraries. Therefore, it is good practice to separate environments with Conda and pip code from each other. So if and when you need to use the pip, create a new separate environment for the pip code, and in your own interest, don't install pip code in your Anaconda base or root environment. In this video course, we recommend to use packages from the Conda management system, its default channels, and the Conda Forge channel. Now we'll talk some about command line terminals and run a few Conda instructions as the final part of this video lecture. And the Anaconda Navigator has several command line terminals installed, plus some ready to be installed, and Visual Studio Code can be downloaded and used with Anaconda as a command line terminal. In this video we will use the PowerShell included in the Anaconda Navigator, and recommend to download the Visual Studio Code as a backup and tool more or less outside of Anaconda's control. VS Code is an excellent backup in the event of an Anaconda failure and has been stable for a very long time. And before we begin to type some Conda instructions in the PowerShell prompt, we will say that when you intend to install libraries, you should always visit anaconda.org and search for the libraries there. There are many channels listed on anaconda.org with useful libraries. Now we're going to start the Windows PowerShell prompt for a demonstration of Conda instructions. So start up the Anaconda Navigator. All right. Having started our Anaconda Navigators, we will start the PowerShell prompt. And here we have our PowerShell prompt. We launch it. And here we can see base within parentheses. And that means that we are in the base or root environment. And we can begin to type Conda info. And this instruction will give us good information about Conda, and in particular the Conda version which we are using. And here we can see that we are using 23.7.4, and we can see the Conda build version, our Python version, which is 3.11.5. We can see our base environment and where it is located, and many other such things. And we can type Conda list. And this instruction will give us a list of all installed libraries, plus their versions, and which channel the library has been installed from. Here we can see all our libraries. We can see SciPy, for example. We have version 1.11.1 installed. We can see Python, and we have version 3.11.5 installed. We can see Honda, and we have version 23.7.4 installed. And we can see Anaconda Navigator, and that we have version 2.5.0 installed. And now we can type conda environment list. And this instruction shows us two environments. First, we have the base environment, which is marked with a star as active, which is our root environment. And we have another environment, which is named DSML environment. And now we know that Conda Navigator has a lot of updates. So we will type Conda, search Conda, to find all available versions of Conda in our channels. And here we can see that we have a new version, 23.10. And according to its documentation, one of the main new things is that libmamba is now the default solver. So according to the documentation, installing Conda 23.10.0 will speed up installation and Conda operations. So we type Conda, update Conda. And this instruction will update our Conda program and turn libmamba into our default solver. And our solver has completed its calculations. And it has found a large number of libraries in need of updating, and some packages will be removed, and some new packages will be downloaded and installed. And we push Y for yes to proceed. And Conda is preparing, verifying, and executing this transaction. And soon Conda will give PowerShell back the control so we can continue. Like this. And now we will update Anaconda Navigator. So we type Conda update Anaconda Navigator. And now libmamba is the active solver. And we will update to version 2.5.1. So push yes to proceed. And as you can see, libmamba is a very fast solver. Now we'll show you how to change versions between two specified versions of the same library. And this is very useful if an update is bad, fails, or is riddled with bugs, for example. And in this video lecture, we will show how to change library versions with SciPy. So we type conda search SciPy. And this will provide us with a list of available SciPy versions. And we know that we have version 1.11.1 installed. And now we will downgrade this SciPy version to 1.10.1. We type conda install SciPy equals 1.10.1. And you can see version 1.10.1 in the list here. So we will now downgrade SciPy. And we push Y to proceed. And SciPy was successfully downgraded. And now we'll return it to version 1.11.1. Like this. Conda install SciPy equals 1.11.1. We push Y to proceed. And SciPy has been restored to the original version, and we have learned to execute version control for libraries, one of the most frequent needs for Conda knowledge. But in the list of SciPy libraries, we could also see a more recent version, a 1.11.3. We can try to update SciPy. We can type Conda, update SciPy. And we will install version 1.11.3, and we push Y to proceed. Like this. And now we have learned to downgrade libraries, to upgrade libraries, and to update libraries. And now we will teach you how to create an environment. So let us type Conda, create, N for name, Python environment, we can call it. And in this environment, we will put the latest versions of Python, IPy kernel, Jupyter Notebook, Pandas, Matplotlib, SciPy, NumPy, Scikit, Learn, Seaborn, and Stat models. And this is an environment which is very suitable for data handling, data science, and machine learning. So now we'll create this environment which will contain the latest versions of all these libraries. And in particular, it will have Jupyter Labs Notebook installed and ready for use. So let's create this environment. And here we can see that the several libraries were in need of being updated and installed, and some also downloaded. We push Y to proceed. like this. And now we'll activate our new environment. So we type conda, activate Python environment. And we type conda environment list. And here we can see that we now have 3 environments: the base environment, the DSML environment, and the Python environment. And we can see that Python environment is marked with a star and is our active environment in this PowerShell prompt. Now we can close the PowerShell prompt like that. And here in the Anaconda Navigator, we can enter the environments. And here we can see that in the Anaconda Navigator, the base root is still active, and the Anaconda Navigator is also unaffected by our update. But the next time you start the Anaconda Navigator, it will be the new version. And now we will activate the Python environment, and we can do this in the Navigator with a single click. And now we can see that the Python environment is activating. And now the Python environment is active. And we can go back and we can test our installation of the Jupyter Notebook. We can launch it. And Jupyter Notebook reports itself for duty. So we can type print hello world and welcome to the course. And we will run this code, and the machine types hello world and welcome to the course. And if you want to, you can now play around with the Jupyter Notebook and test whatever you want to test. And now it is time to congratulate you for completing this video course about the Anaconda Distributions Library Management System Conda. We will continue to the next video in the video course, and we look forward to see you in the next video. Hello and welcome to this video course about Python for data handling. We're excited to have you here, and in this video course you will learn to use Python's native building blocks and powerful object-oriented programming with the intention of making you able to use Python for data science and machine learning data handling tasks. This video course is an excellent entrance to Python. If you already have some knowledge about Python, this section of the video course will be very easy for you. If you know another programming language, this section will be a very easy road to learn the Python programming language. If you don't have any prior programming knowledge or have some experience with tabular software or Office packages, this video course will give you an excellent start as a programmer focused on data handling tasks, or an excellent start as a data scientist or data analyst using Python to manipulate data to fit your particular program or libraries. So what is Python? Python is a programming language, and Python is considered to be an object-oriented language, and in Python this means that every item that you use is defined as an object. Python is dynamically typed, and this means that we can execute parts of the program's code at runtime rather than compiling the code before running the code. And this is a very useful and powerful property that makes us able to test parts of a Python program and develop code more quickly than if we had to test the entire program at runtime every time. And in particular, we will use this property to enhance the learning of Python in this course by us, the teachers, being able to execute parts of the code and show what it does step by step, rather than running the entire code and looking at the parts afterwards, which gets complex after 25 to 50 lines and seriously tough after 100 to 400 lines of code. So, dynamically typed code makes it very easy for us to develop code step by step, and dynamically typed code has very pedagogical properties. In addition to these great and useful properties, Python is a simple and easy to learn high-level language. This means that the code is very easy to learn and easy to understand and doesn't have any explicit machine language components in itself. Python is also very fast for its types of language, and many Python libraries have special optimizations written in faster programming languages. Python is very user-friendly, and Python has very many powerful libraries for data science and machine learning with already written code for data handling. Python is easy to use together with other programming languages. If you have code previously written in other programming languages, it is often very easy to either port the code to Python or to use library code to interface with code from other programming languages and keep using already written code. And Python is also a great general-purpose language, which means that Python is all you need for your programming needs, regardless of if you are doing data science, machine learning, simple data handling, web pages, or any other type of programming of code. Yes, Python with its environment and libraries can cover all your programming needs. So why is Python great for data science? Python's programming code language is natural and intuitive, and this means that Python code is very easy to learn, to read, and to use as compared to many other programming languages. Python is simple to use, and the dynamic typing enables quick testing of code as compared to any compiled languages. Python has one of the best and most active communities creating, supporting, and maintaining libraries for data science and machine learning. This is very useful because libraries and packages will often be updated and have many of the latest features. The main possible trouble with this is that code often changes and sometimes or rarely unexpectedly, and this creates both opportunities, both for good and for overtime, and this can be easily mitigated by working with specific versions of libraries rather than the latest experimental or night version of a library. Another great thing with Python with respect to data science and machine learning is that there is a large number of development environments for Python code, and there is a good chance that you will find one that suits your particular wants and needs of your environment. In this video course, we will mainly use the cloud-based Anaconda Cloud Notebook or the full-scale developer environment, the Anaconda distribution. Both of these environments contain a large number of coding packages, libraries, tools, and environments, and can be further extended with downloads and package managers. In this video course, we will use JupyterLab's Notebook, which is one of the most useful and well-known code development environments. JupyterLab's Notebook has a great implementation of dynamic typing, which we will use to enhance our coding pedagogics. JupyterLab's Notebook is included in both the Anaconda Cloud Notebook and the Anaconda distribution. Another thing that makes Python great for data science is its community's doctrinal and philosophical support, which dictates and encourages what constitutes good and best practices for Python code. The leading words in these philosophies and doctrines is that simple is better than complex, and complex is better than complicated. And these doctrines create an overall code development environment, which is helpful for purposes of data science. So alright, now we'll talk about Python concepts. And to effectively use Python for data science and machine learning, some theoretical concepts are needed. And these concepts are data types, including data storage abstractions and data transformers, as well as object orientation. And in Python, all data types and data storage abstractions are defined as objects. So here we have objects that contains data values, which are objects, and we have functions that can change objects and change data values. So these are the two main concepts in Python. And data types can be integers, floats, complexes, and strings. In this video course about Python for data handling, you will learn to use integers, floats, and strings. You will learn Python's native data storage abstractions such as the set, the tuple, the dictionary, and the list. You will learn about Python's data transformers and how to make custom functions. And you will learn about Python's object orientation, how to make custom objects, and how to move data around between common file formats. Python data types are objects. Integers, floats are objects, and in Python data types are also Python data storage abstractions. And these are Python's natively defined tools used to store collections of integers, floats, complexes, and strings. Or, for example, your own custom user-defined objects. In this video course, we will take a good, deep, and thorough look at sets, tuples, dictionaries, and lists. So, data transformers and functions are necessary for machine learning and data science. These are used to change or create variables, or just used on variables to compute new variables, new values, or to control logic, and for creating new objects or for analyzing texts or graphics. In this video course, you will learn to use loops, logic control, and to define and use your own defined functions, which is considered to be an intermediate or even advanced type of knowledge. You will learn about Python's object orientation and to create intermediate bordering to advanced custom objects. In practice, you will learn to create your own object-oriented programs and to handle customized objects in terms of data handling. You will learn to serialize objects and to transform data to tabular form for use with standard data science and machine learning programs and libraries. And you will learn to save data and objects to binary files, .csv files, Excel files, and to load files to Pandas data frames. And these are the main formats used by most data science and machine learning programs, and are more or less guaranteed to be compatible with all well-known data science and machine learning programs or libraries. And this ensures the usefulness of your knowledge gained in this video course. Can you see the yellow and blue Python sign in the bottom right empty corner of the screen? That is a symbolic empty space for future developments of this video course and Python. Because Python is a developing language, and while the main developer has promised that there will be no major changes to Python 3's core, as when Python went from version 2 to 3, it is an open space for a future evolution of this video course. So what is data handling? Data handling has many definitions. Most overemphasize data handling as being the entire research or data creation process, from alpha to omega, or from the beginning to the end. Or they emphasize the data science or statistical parts of the process. The main reason for these generous definitions is that only 1 in 1,000 researchers actually knows about or has studied the entire research process. One of the better yet slightly flawed definitions, directly Googleable, is data handling is defined as the research process that is used to collect, record, organize, and analyze data, which rather defines the entire research process with data handling included as a part of the research process. So, data handling is about organizing data. Organizing data has both methodological and technical aspects, and the organizing of data affects all parts of the collection, recording, and the analysis of the data. Here we must be careful to separate the process of creating research from the system which we actually has in place and must technically work with. So here we have two systems, one that discusses how to conduct perfect or good science, and we have another technical system which we must work with, where we have a system in place and we must technically work with this system and organize the data inside of it. Using Python for data handling is about using Python to technically organize data. And this means to move, copy, modify, change, transform, save, store, and load data. Data handling with Python requires Python coding skills, it requires assisting libraries, and it requires know-how about data and an idea or plan on how to create information from data. In this video course you will learn the Python programming language with the aim of mastering the necessary skills and the ability to execute technical data handling. And technical data handling is for practical reasons in 99.99% of the time or cases centered on the tabular form, and most commonly organized around a set of spreadsheet-like columns which together form a matrix. And this matrix we can use with standardized methods to analyze, synthesize, or graph data. And when you study software and libraries, you will find that every function and method expects a column or tabular data form as input and delivers such as output, unless we are talking about exceptional specialized systems expecting other types and shapes of data. Python for data handling is about learning Python and learning to use Python to move data into a tabular form, which can be further analyzed with standardized software. A usual data handling task is that a customer has an Excel spreadsheet with data that the customer wants to combine with other data, partly modify and transform into a tabular model for use with one of many possible analysis software programs. And it could be SAS, it could be Pandas, NumPy, SPSS, Matplotlib, Oracle, GPTX, scikit-learn, stats models, Tableau, Minitab, Microsoft Business Intelligence or Excel. It could be standard query language or any software imaginable. In this video course you will learn how to use Python for these tasks. My opinion is that Python together with the Python library Pandas is the most useful and powerful toolset for data handling tasks currently available to a data scientist or machine learner. Alright, now we'll take a brief look at the table of contents for this video course. And we have the following videos. First we have this combined theory lecture and overview of Python for data handling. In the following video lectures you will learn about integers, floating points and strings. In the part about data storage abstractions you will learn to use sets, tuples, dictionaries and lists. In the part about data transformers and functions you will learn about Python loops, some Python logic operators with Boolean logic together with Python's conditional branching of code, and you will learn how to create your own user-defined functions in Python. In the part about object-oriented programming, you will learn theory about object orientation, how to create your own customized objects, and how to serialize objects and transform data to a tabular form, and how to handle file formats such as the CSV and Excel formats to load and save files, all very useful knowledge for data handling. Before we continue to the next video, we will talk some about the Jupyter Labs notebook, the organization of Python programs, and the special peculiars of Python coding. We will begin with the Jupyter Labs Notebook, and the Jupyter Labs Notebook is a very powerful tool for programming, data handling, data science, data analysis, and machine learning. It is also an effective platform for inter alia writing, creating, and sharing documents with running code, equations, visualizations, and rich text elements. In this video course, we will learn to use some of the power of Jupyter Labs Notebook delimited to the perspectives of data handling. By definition, the Jupyter Labs Notebook is an integrated development environment, IDE, and is a one-program toolbox of tools for software development. The Jupyter Labs Notebook's graphic interface has menus, buttons, and uses a series of input and output cells for data encoding purposes. The input cells can contain code, text, or formatted text, and the output cells contains the output from input cells. When we program in Jupyter Labs Notebook, we type our code in the input cells, and when we run the code in an input cells, the result is shown in the corresponding output cell. The input and output cells are executed serially in a top-to-bottom fashion and are executed one at a time as the standard. We can change the content of input cells in a serial chain, or we can delete cells while the top-to-bottom dependency in the chain remains, with a need for re-execution of the code when the code is changed or input cells deleted. Jupyter Labs Notebook's implementation of dynamic typing is likely the currently best implementation of dynamic typing in the world and allows for very fast development of code and data. In this PowerPoint, we have a standard Jupyter Labs Notebook visualized with the conceptual input-output cell model shown next to it with the PowerPoint symbols. And the arrows in this conceptual model depicts the dependencies between the cells and the top-to-bottom dependencies, which are shown with black and red arrows. And this is necessary fundamental knowledge of the Jupyter Labs Notebook's coding interface, and now we'll talk some about the Python programming code environment or the organization of your Python programs. So now we're going to talk about your Python programming code environment. When you create or type your program is a text which is interpreted by Python through the tools in your integrated developer environment, in this case Jupyter Notebook. And your text or program doesn't live in a vacuum, and while you are technically able to access most, if not all, functionality with your own Python code, it is often better to rely on already written code from libraries. In Python, we can do this formally through imports. So we can import functionality from other Python programs or modules, or most commonly import functionality from libraries. And these imports are either of the entire library or module, a subpart of the library or module, and a library or module can also be imported and aliased for increased ease of use and code readability. Through Python, you can connect to your workplace's hardware and through the hardware access networks, the internet, and the cloud. In many instances, the technological development has lowered the border between your local workplace computer or mobile or phone and networks, the internet, and the cloud. In the future, this border may become more or less invisible. And Python and your integrated developer environment also accesses your hardware in a way which makes the access near invisible. For example, Python and your integrated developer environment runs in your RAM memory without any obvious references to it. And the main reference to hardware is through output instructions such as print to screen, save a data file, or input instructions such as load a data file or import a library. And while Jupyter Labs Notebook automatically saves files and also partially run code for backups, it is still important to know where your programs are stored physically for manual control and certainty. And now we'll talk some about Python code and Python syntax. And Python is constructed to have a syntax similar to spoken scientific English. And here in this example we show this with the one-liner print hello world and welcome to the course. And this one-liner shows a syntax similar to spoken English. Of course, Python code can also be written with advanced functions and methods and a language which sharply deviate from spoken English. But the intention with Python was always to have a language which was very similar to spoken English or spoken scientific English. To separate different instructions from each other, Python uses invisible new lines to complete an instruction instead of a special readable character. And this makes the code easier and more human-like to read, but may also have a negative effect on the readability of very long instructions. And hence we have a preference for short and clear language when we type in Python. And in the example on screen and in the first input cell we have 6 instructions, each on their own line beginning with import math as the first instruction and pi_1 equals math.py as the last instruction. Imports are important in Python and are, according to readability standards in Python, always placed in the top part of a Python program. And in the example on screen we import 2 libraries, the math library in full and the Pandas library in full, and aliased as PD. And Python uses indentation or whitespace tabs, simply tabs on your keyboard, to define the scope of constructs such as loops, functions, conditional branching, and classes. In the example on screen we have an if and else statement with colons where the scope of the code is defined by an invisible whitespace tab, moving the executable parts of the statement to the right, which makes the code more readable. In Python, comments are frequently used to explain and clarify code. Every comment starts with a commentator's sign or hash mark. Every line of comments need a new hash mark, and using a hash mark turns all code or text to the right of the hash mark into non-executable text. In our example we have on screen, we have comments to the right of the code, and we have multi-line comments shown with new hash marks for every line. Python has no instruction for constructing or declaring a variable, and variables are created through assignment. And Python variables are considered to be global in nature, and this means that they are accessible from anywhere in a program, except for variables inside functions which are local in nature. Python classes can be designed to be private both with respect to data and methods, and we can call them non-global. And the naming of Python variables is a special process, and Python variable names have very few rules hard-coded into Python. But there are some hard-coded rules which makes some variable names unusable, as Python will interpret them as coding errors. And in our example on screen we have a few of these unusable names shown. One starts with a number, one has a not allowed string character, and the first has a not allowed whitespace space string character in it. And when it comes to the large family of usable names, there are some soft rules for variable names which should be followed according to the Python doctrines. And the first rule is that a variable name should be descriptive of the variable content, or otherwise be short named, be very short and concise. The other rules are that a variable name must start with a letter or underscores. Variables may not start with any type of number. A variable name is case sensitive. And variable names may only use alphanumeric characters and underscores. And in our example we have some few allowed variable names described, and we have also an example of more complex and descriptive variable naming schemes. And which scheme a coder uses is generally depending on the coder's background. For example, one of these schemes is from Java. So here we have code which someone who was schooled in Java and had converted to Python has written. And the other scheme is from C++. And staying true to one scheme in one program is the most important naming doctrine soft rule of them all, because it is all about readability. And all of these different schemes are equally good. So now we have learned the necessary fundamental formalia for continuing this course. And now it is time to congratulate you for successfully completing this first practical video lecture of this video course Python for Data Handling, with the included overview of the course and the descriptions of the Python programming language and its coding and data science and machine learning community. And in the next video lecture you will learn about Python integers, the most fundamental of all of the necessary tools for data handling, data science and machine learning. And we look forward to see you in the next video. Hello and welcome to this video course about Python for data handling. We're excited to have you here, and in this video you will learn to use integers, which are a fundamental tool to be able to use Python for data handling. Python integers are necessary as a tool for basic counting and may, for example, be used to represent counts of items, the number of iterations of a function, the location of an object in a list or array, or as a representation of change in a function. Integers are a fundamental data type in Python. The short form of an integer or the abbreviation for an integer is int, and an integer can be a whole number without decimals, and integers may in the current version of Python have unlimited size, which makes Python's integers very easy and convenient to use, as there is only one type of integer, not 2, 4 or 8 integer data items. So a Python integer can be any type of numbers, such as 34 minus 91. It can be 1, it can be millions and billions, but what it cannot be is an integer with a fraction. And Python creates integers by assigning an integer value to a variable, for example the variable whole num in this example. And we will assign the variable whole num the value of 5, and we will comment some on it. So in this example, which we have in this PowerPoint, we take the variable whole num and assigns it the integer value of 5 with the equality sign. Whole num equals 5. And then we write the commentatory sign, which is the hash mark, and to the right of the hash mark we type integer value to remind us that 5 is an integer value and that the variable is an integer. And we can use the print command and print the value of the variable by putting the variable between the parentheses of the print command. And when we run this code, it will print 5. So we use the print command to show that the variable exists and that it has a value. Now it is time to type some code, so let's start our Jupyter Labs notebook. And after starting our Jupyter Labs notebook, we will run this integer code in the Jupyter Labs notebook. Alright, having started Jupyter Labs notebook, we are now ready to start typing the code from the PowerPoint into our Jupyter Labs notebook and run the code. So we start typing whole num equals 5. And we type the commentatory sign, which is the hash mark. And we type integer value to remind us that 5 is an integer value. And we type print whole num. And this code will print the variable whole num's value to our window when we run this code. So let's run this code. And as you can see, we have an integer value 5 printed to the screen. And we can create more integers and add them together to create new integers. So we type num2 equals 3, and this is an integer value. And we type num3 equals num2 plus whole num. And we can type print num2, and we can type print num3. And num3 will be an integer value of 8. And we state that an integer value plus an integer value is an integer value. So let's run this code. And as you can see, we had the integer values 3 and 8 printed to our screen. And we can continue with minuses. Multiplications and divisions. So we type num4 equals whole num minus num2. And this will be 2. And we can state that an integer value minus an integer value is an integer value. And we can type print num4, and we run this code. And we had the integer number 2 printed to our screen. And now we'll try some multiplications. We type num5 equals num4 times num3, and this will become 16. And we type that an integer value multiplied with an integer value is an integer value. So we print num5 and we run this code. And the integer value 16 was printed to our screen. And now we'll try some division. So we type num6 equals num5 divided by whole num. We have 16 divided by 5. And we state that two integer values divided with each other returns a float if a single divisor sign is used. So we print num6 and we print type num5 and we print type num6. And when we run this code, the numeric value of the float num6 will be returned, and we will print the data types for the variables num5 and num6. And these shall return an integer for num5 and a float for num6. So let's run this code. And here we can see that we have an integer with a fraction, which is a float. And we can see that the variable num5, which is 16 and an integer, is of the class object integer, whereas the variable num6 is a float. So now we have learned that two integer values divided with each other returns a float if a single divisor sign is used. And now we are going to try some floor division, and we will create a variable num7 which will be equal to num5, and we use two division signs for floor division, and we use the whole num variable again, and we type 16 divided by 5 equals 3. Two integer values floor divided with each other creates a rounded integer. And we print num7 and we print the type of num7. And we run this code. And the integer value of 3 was printed to the screen, and we can see that the integer created through floor division is indeed an integer. By printing its type, we can see this. And we can use integers to keep track of, for example, loops. So we can type for x in range of 1 to 6, print x. And when we run this code, it will print a series of integers for us. So let's run this code. And here we can see that it printed 1, 2, 3, 4, 5 for x in range of 1 to 6. And this is one of the reasons that integers are extremely important. They are used to keep track on, for example, loops, positions in arrays, numbers, and all such things. So, now we'll use the edit menu and the delete command to clear this code from the notebook to prepare for the next part of these practical hands-on Python video lectures. So we will delete cells. Like this. And in the next video you will learn about floats. And we look forward to see you in the next video. Hello and welcome to this video course about Python for data handling. We're excited to have you here, and in this video you will learn to use floating points or floats, which are a fundamental tool to be able to use Python for many types of data handling. Python floats are necessary as a tool for basic numeric value calculations and modeling. Floats may be used to represent any type of numeric values. Floating points are a fundamental data type in Python. The abbreviation for a floating point is a float, and a float represents a real number, and it can be a whole number and a fraction, or an integer value and a fraction. And the float is a real number and is written with a decimal point separating a whole number and the fractional part. And this is very important. You see, you have an integer and you have a fraction. And that is what creates a float. And you can also create a float by using scientific notation. And the reason that floats and integers are treated as separate is because they are using separate circuitry for the calculations. And this creates a need for different data types to effectively code for the hardware circuitry. And here is a PowerPoint example of floats, and it shows how to create a float. And now we'll type this code example in JupyterLab's notebook, and we will jump directly to an active JupyterLab's notebook without passing Windows 11 and the Anaconda Navigator screen. So start up your code editors, because we're going to type some floating point code. Alright, having started our JupyterLab's notebooks, we will now type some floating point code. And we will begin by typing real num equals 5.3. And we can type the hash mark for the commentatory sign. And we type float value. And we can print it. So we type print real num. And when we run this code, it will print the float value 5.3 to our screens. So let's run this code. And as you can see, it typed the float value 5.3. And we can create more floats and add them together to create new floats. So we can type floating point 2 equals 3.2. the commentatory sign, and float value. And we can type floating point value 3 equals floating point value 2 plus real num. And we can type 8.5 and a float value plus a float value is a float value. And we type print and we run this code. And as you can see, we had the float value 8.5 printed to our screens. And now we'll try with minus. So we type floating point value 4 equals real num minus floating point value 2. And this is 5.3 minus 3.2 equals 2.1. And a float value minus a float value is a float value. So we type print floating point value 4 and we run this code. And here you can see the interesting thing with floating points, that they are rounded in a very interesting fashion. So you don't get an exact 2.1 here, but a semi-exact 2.09. And this means that you can need to round these values in some applications. So now we go for multiplication. So we type floating point 5 equals floating point 4 multiplied with floating point 2. And we type a float value multiplied with a float value is a float value. And we print floating point 5 and we run this code. And we returned a value where we multiplied this value with our 5 with our 3.2. So now we're going to do some division. So we type floating point value 6 equals floating point value 3 divided by floating point value 2. And we can type that a float divided by a float is a float value. And we add value, so we have the sentence correct. And we type print floating point 6. And we run this code. And here we can see that 8.5 divided by 3.2 is 2.65625. And now we're going to try a loop. So we type floats are used in almost all calculations. For example, for x in range of 1.6, print x multiplied by floating point 4. And we run this code. And here we have floating point 4, which is this not rounded floating point from our calculation. And here we have x equals 1 multiplied with this value, x equals 2 multiplied with this value, and x equals 3 multiplied with the floating point 4 value, and so on. So now we'll use the edit menu and the delete command to clear this code from this notebook to prepare for the next part of these practical hands-on Python video lectures. So we delete the cells. And in the next video we will talk about strings, which is Python's main way of handling text data. And we look forward to see you in the next video. Hello and welcome to this video course about Python for data handling. We're excited to have you here, and in this video you will learn to use strings, which are a fundamental tool to be able to use Python for most types of text-based data handling and texts in general. Strings are used in almost all types of machine learning, data science, and data handling. And being good at handling the string data type is a sure way of being effective at any type of data handling. Strings are a fundamental data type in Python, and strings is the main non-numeric data type. In Python, a string is a set or an array of characters between quotation marks, and a one-character set is also defined as a string in Python. As a consequence of this definition, Python strings are immutable sequences, and this means that in practice, every time a string is changed, a completely new string object is created for the new string. And this is an important feature to keep in mind when you work with strings, because strings are one of the most commonly stored and created data objects, and also one of the most studied data objects within data science and machine learning. When you work with strings in Python, Python will create a string by assigning a set of characters between quotation marks to a variable. And now we'll show and simplify this by creating a string variable which we call example string. And the string will be created by using the sign of equality and the set of characters hello world between two quotation marks. And now we'll use this example in JupyterLab's notebook, and we will jump directly to an active JupyterLab's notebook without passing Windows 11 and the Anaconda navigators. So start up your code editors, because we're going to type some string Python code. Alright, having started our JupyterLab's notebooks, we will now type the code from our example. So we type example string equals hello world. and we will type the commentatory sign, which is a hash mark followed by a string made of characters. So we type a string variable, and we can type print example string, and when we run this code, this program will type hello world to our screens. So let's run this code, and as you can see, we got hello world typed to our screen. And we can add strings together. For example, we can create an example string 2, which we call again with a comma. And we can type example string 3 equals example string plus example string 2. And we can print example string 2 and 3. So let's run this code. And here you can see the first string, hello world, the second string which we made, comma again, and the third string which consists of these two earlier strings added together. So here we has the third string which says hello world again. And we can show how a string is constructed from parts with a loop. So we type for x in range of length of example string 3 and we print example string 3 dot x, and this code will calculate the length of example string 3, the number of characters in it, and it will use this length as the range, and it will type every character on a new line inside this string. So let's run this code. And as you can see, we had hello world typed character for character on our screen. And we can take this demonstration a bit further. So we type example string 4 equals an empty string, and we type for x in range of length of example string 3 and we type example string 4 equals example string 4 plus example string 3. x, and we print example string 4 plus string length example string 4 and this code will, for every increasing x, add this number to our example string 4, and for every iteration it will also print the example string 4 plus an empty space or a white space, and the length of example string 4, and convert it to a string because the length is a int. So let's run this code. And here you can see that our string, when it is only one character, it has the length of 1. When it has 2, it has the length of 2. And that the entire string has the length of 18. Hello world again. And we can make some changes to this code. We can type for C in range of length of example string 3 print example string 3 plus 1, and we can add a white space and we add cast to string for an int, like this. And when we run this code, it will produce a similar output as the code one cell above this code. So let's run this code. And as you can see, our new code produced a similar output with one less line of code. So as you can see, there are many ways to code similar solutions. And now we will type this text backwards, or at least attempt to type it backwards. So we type for E in range of length of example string 3 print example string 3 plus a white space plus a cast to string for an int example string 3 And when we run this code, we will have the same output backwards. So let's run this code. So here you can see we run the same type of code, but we run it from the other side or in the other direction or backwards, you could also say. And as you can see, there are lots and lots of ways of code similar solutions with strings. And we have a lot of options to operate on our strings. So alright, this has been a fun and interesting video lecture, and we have learned a lot about strings. Let's now delete our program code from the Jupyter Labs notebook and prepare for the next video. So we delete these cells. Like this. And in the next video lecture, we will talk about some intermediate special string functions used to transform, change, manipulate, or test the content inside a string object. So these functions are very useful for purposes of data handling. And we look forward to see you in the next video. Hello and welcome to this video course about Python for data handling. We're excited to have you here, and in this video you will learn to use intermediate string functions which are used to transform, change, manipulate, or test the content inside a string object. These string methods are used to search strings for defined content, to test the properties of strings, to change strings, and are a great toolbox for data handling, both in terms of managing string data, but also in more general terms, as the string data shape often is a transitional data form in various types of data handling. So now we're going to talk some about Python string object methods. And we will begin to talk about some string methods used to test the content of strings, tests which may be important when using strings in terms of data handling. And the methods that we will learn to use are isAlpha, which tests if a string consists of only letters, and the isDecimal method, which tests if the string consists of only decimals. And these functions are useful when converting data between string formats and numeric formats for computation. Two other useful tests we will look at are the isLower method, which tests if characters in a string are lowercase, and we will also look at the isUpper method, which tests if the characters are uppercase. And these tests return true if the test is true and false if the test is false. And we will look at methods for searching the contents of strings, such as the findEx and rfindEx methods, which returns the integer position of a finding of a string x inside a string, or -1 if no finding is made. Another function is the countX method, which counts the number of times the string x occurs in the tested string and returns an integer describing the number of counted occurrences of the string x. And we will also look at methods for changing the contents of strings. And we will look at the capitalize method, which returns a string with the first letter capitalized and the rest lowercase. We will look at the lower method, which returns a string with all letters lowercase, and we will look at the upper method, which returns a string with all letters uppercase. The replace x and y method returns a string which have all occurrences of string x replaced by string y within the string which the method is used on. The strip, lstrip, and rstrip methods returns strings which have had its whitespace removed from them at the beginning of the string or at the end of the string, or concerning the strip method at both the beginning and the end of the string. And these methods are very useful for data handling. So right, now we'll start our UTLabs notebooks and type some string code. So let's start up our code editors. All right, having started our UTLabs notebooks, we will start by creating some strings. So we type example string 1, hello, and it is intentionally spelled with capital letters in a strange fashion. String 2 equals world with uppercase letters. Example string 3, again with lowercase letters. Example string 4, a float as a string. Example string 5, an integer as a string. Example string 6, hello world again. An example string 7, hello with white spaces before hello and after hello. An example string 8, is world with white space before world and comma and white space after. Like this. And let's begin with the tests of our strings. So we type print example string 4 is alpha, and we print example string 4 is decimal. Is it true or false? True or false? I've used the isNumeric test for a string. And we use string 5 isNumeric. And this will teach us to keep integers and floats separate. So let's run this code. And here we can see that E string 4 is a float cast as a string, and it is not alphanumeric. We tested it for if it is a decimal, and because of the dot, it is not. We tested if it is numeric, and because of the dot, it is not. And we tested string 5, which is an integer cast as a string, and it reported itself as true when we checked whether it is numeric or whether it was decimal. And we can rerun this code without this dot, like this. And as you can see, our float turned into an integer, a proper integer without the dot, and the is decimal and is numeric turned true. And we can conduct some more tests. We will print string 2 is upper. We can test string 1 if it is upper, and we can test string 3 if it is lower. So we will first test string 2 and check if it is uppercase letters, and all these letters are uppercase, so it should report true. And string 1 has some uppercase characters, but not all, so it should report false. And string 3 only has lowercase characters, so it should report true. So let's run this code. And here we can see that string 2 is upper is true, string 1 is upper is false, and string 3 is lower is true. So we can type. The tests are defined as native string methods and can be used to check the contents of strings before using, for example, cast methods on them. As an example, to convert the string to an int or float. And now we will look at methods for searching content inside strings. And the methods return integer positions of findings and -1 for non-findings. So we type print E string 6 find world. And here we look for the first occurrence, and we type E string 6 find rfind low, and this will find the last occurrence if there are several. And we print the string 6 find aircraft. And there will be no occurrence of aircrafts in this search. So let's run this code. And we get 6, 3, and -1. Here we have string 6. In the first search, we wanted to find the position of the world, which is here. Position 6, 1, 2, 3, 4, 5, 6. And we start the count from 0. So it finds the world. The second search was for low. And the count was to the last occurrence, but we only had one occurrence in this string. And here we have low, 1, 2, 3. 0, 1, 2, 3. And we have no aircraft in the string, and therefore we got -1. And we can also count the occurrences of a string inside a string. And here it is important to remember that while a string is often a word, a string can also be a sentence, a paragraph, a book, or an entire library. And this makes these search functions incredibly powerful. So we type print string 6 dot count the character L. So let's run this code. And it returned 3. And here we can see we have 1 L, 2 L, and 3 Ls. So now we know that it counted the occurrences of the string L correctly. And this is an incredibly powerful function to find exact strings. We have some methods that can change the contents of a string, or rather create a new copy of the string under transformation. So we type print string 1, capitalize. We can type print string 2, lower, and we can type string 3, upper. So the first line will take the first string 1, and it will capitalize the first character and make the rest of the characters lowercase. The second line of code will convert this uppercase word to lowercase. And the third line of code will convert or transform a copy of string 3 into an uppercase string. So let's run this code. And here we can see that Our first string, string 1, was capitalized. Our second string was turned into a lowercase string. And our third string was converted to an uppercase string. And we have methods that can replace strings content in copies of that string. So we can type print string 6 replace L with 1. And we can print string 7 plus string 8. And we can print string 7 dot L strip plus string 8 dot R strip, and we can print string 7 dot strip plus whitespace plus string 8 dot strip. So let's run this code, and in the first case we will have all the else of our string 6 replaced with ones. In the second line of code, we will just print string 7 plus string 8. And if you remember, these are strings with a lot of white space. And on line 3 and 4, we will remove that white space with different methods. So let's run this code. And here we can see that the else have been replaced by ones. This is the original 7 and 8 string. The L strip removed the white space before hello, and the R strip removed the white space after world. And the strip on both removed all the white space before hello and after hello, and before world and after world. And to make these words separate, we added a single character of white space. And we can say that the applications of string functions or methods are near limitless. So all right, this has been fun, and we have learned a lot about string functions and methods. So let's now delete our program from the Jupyter Labs notebook and prepare for the next video. And in the next video, we will talk about some special string objects used for specialized tasks. We look forward to see you in the next video. Hello and welcome to this video course about Python for data handling. We're excited to have you here, and in this video you will learn some knowledge about Python's datetime module, which is very useful knowledge in many data handling tasks. In particular, combined with knowledge on how to use strings for data handling. Python's datetime module, what is that? The datetime module provides you with classes for manipulation of dates and times. It can do some arithmetic calculations, but alleges to be focused on output formatting and manipulation. Python's datetime module is very useful for data handling purposes, and we will teach you how to mount date and time data into the datetime class or objects, even when that time data doesn't conform to Python's datetime object standards. So, Python's datetime module has three highly relevant parts plus a time delta part. And we will take a look at datetime.date module, which handles month, day, and years. And we'll take a look at the datetime.time module, which is concerned with hours, minutes, seconds, and microseconds, as well as optional time zone info. And we will take a look at the datetime.datetime object, which is concerned with all aspects of the date and time module. So now it's time to write some datetime code. So let's start our Jupyter Labs notebooks. Alright, having started our Jupyter Labs notebooks, it is time to write some datetime code. So let's begin to import the datetime module. And we will type import datetime module as DT. So we type import datetime as DT. And we will define datetimes either by a function or through data insertions. In our case, inserted ints, which could be created from string time data, such as older time data standards. And these could be, for example, 1988, 1124, or 24/11/1988, or 188/24/11. We will type current date equals datetime, date today. And we can create a birth date, datetime, date. And here we perform an insertion. So we type 1988, 11/24. 24th November 1988. And we can print the current date, and we can print the birth date. So let's run this code. And here we can see some time data standards and the one that we have in our datetime object. So here we have the current date at the date this video was created, and we have a fictitious birth date 1988, the 24th of November. And here we have some older date standards which may occur in saved data files of older type. For example, adding a 1 and a 2 could be one way to separate the centuries after the year 2000. And some standards type the month before the days. And on some dates, this can be a problem because you cannot automatically separate days from months. And if there is only a few records, this could be a real trouble. And there are thousands of date and time standards for how to store times and dates. And some are easy to handle, some are American, some are European, some are Asian. And sometimes every country, for example, in the European Union, in older times before the European Union started to standardize things, had their own date and time standards. And all of this creates a need to be able to convert date times into, for example, the Python datetime object standard. So what we have shown here is how this can be done in a very easy way. So you will have a string that may look like this. And from this string, you will extract the day, and you will cast it into an int. You will extract the month, and you will cast it to an int. And you will extract the year and cast it to an int. And when you have these three things, you can create the date according to our datetime object standard. So we can type, if we have time data of the older or other standards, we convert the data to a string format. We extract the relevant time data with our string knowledge and cast it to relevant strings and ints and enter the data into the date time or datetime module objects. Similarly as with the birth date above. So this is how we easily can convert our data into the datetime modules standard. And Now we will take a look at the date part of the date module. And we can ask the datetime object, the datetime date objects about their date data. So we type print birth date dot month. We can print current date dot day, and we can print birth date dot year, and we can print birth date. So let's run this code. And here we can see that we printed an int, which is the month of the birth date. We printed 25, which is the current date, the day this video lecture was captured by the video camera. And we printed the year of our fictitious birth date, which is 1988. And finally, we printed the birth date. And we can type that the time object is interesting. We can type 0 time equals datetime.time. And we can print 0 time today, which is hour, minute, second, and microsecond. And we can print datetime.datetime.now, which gives us the date plus time. And we can type 0 time today equals datetime, date, today. And we can type 0 time today equals datetime dot datetime ct today dot year 0 time today dot month today dot day. And we can print 0 time today. So let's run this code. And the first thing we do is that we calculate the 0 time today. And it will be 0 for all days every year. And the second thing we did was that we calculated the date time right now at the microsecond of when this instruction was run at the time when this video lecture was recorded. So here we have the exact microsecond when this instruction was run to the CPU. And these other lines created 0 time. So the first thing we did was that we created a date object with the year, the month, and the day, today. And we use these properties to create a zero time for our current date at the time of the recording of this video lecture. And we can say that the datetime object holds large amounts of useful data. We can type current datetime equals dt.datetime.now. And we can print current datetime. So let's run this code. And here we can see that a few minutes has passed since we ran the same code the last time. And now we will calculate time today. We type time now equals dt.datetime.now. Time since zero time equals time.now minus zero time today. And we can type print time since zero time. And we run this code. And here we can see that the time when we run this instruction is 22:02 and 12 seconds plus a number of microseconds. So here we have used a calculation to calculate the time using the datetime object. And this is very useful as you can create these times arbitrarily and therefore use them for any type of useful purpose. So you don't have to define zero time as zero, and you don't have to define current time as now. And if we want to edit this output a bit more, we can remove the microseconds, for example, by zeroing them out. So we type time since zero time minus equals datetime.time delta microseconds equals time since zero time dot microseconds. And we can print time since zero time. And this code will take our time since zero time, and it will create a new datetime object using the time delta constructor. And this new time object will only have the microseconds. So we will remove the microseconds from our time since zero time with this minus sign before the equality. So let's run this code. And here we can see that the microseconds has been removed from the output. So now we have learned to edit the output from the datetime object. And we can calculate time differences using datetime objects. So we can type days old equals current date minus the birth date. And we can type that days old equals days old dot days. And we can print days old. So the first thing this will do is that it will take our entire current date with microseconds and everything, and it will extract our birth date from that object. And the second line of code will remove everything but the days from this calculation. And finally, we will print how many days old our fictitious character is. So let's run this code. And here we can see that our fictitious character is 12,753 days old. And we can calculate time constructs such as years. So we can type years old, days old, and we will divide using floor division, and we will use the number of days in a year. So we will calculate the number of years. And we will print years old. So let's run this code. And here we can see that our fictitious character is 34 years old. And we must say that real-world data may use other time formats than standard US date time data. Such data is either to be converted to datetime, data, or have data extracted using string and int operations. In this video lecture, you have learned to create time event data, to calculate time durations using datetime objects, and we can say that time data in data handling is most of the time either about to define the time of an event according to a time standard, and use it with associated data values, or to use the calculated duration between two or more events. For example, the duration of a medical drug, or the duration until the effect of a medical drug, or the total time an experiment with event times within that time frame. And as you can see, this is very useful knowledge, which really can make your workday much easier and faster to have. So all right, this has been fun, and we have learned a lot about specialized strings and datetime objects. So let's now delete our program from the Jupyter Labs notebook and prepare for the next video. Like this. And in the next video, we will talk about collections or data abstractions, which are used to store variables and other objects. And these collections or data storage abstractions are an absolute necessity for using Python for data handling. So we look forward to see you in the next video. Hello and welcome to this video about Python for data handling. In this video lecture we are going to talk about Python concepts and Python native data storage abstractions. These data storage abstractions, or simply data structures, are used to store Python objects or data items. Consequently, these Python native data storage abstractions are often used within data science and machine learning, and therefore very important to understand for data handling purposes. Python uses native data collection data types to store objects such as integers, floats, strings, or other custom-defined objects. These defined objects can be files, images, or any Python native user-defined or program-defined object. And when we say that a data storage abstraction is native to Python, we mean that they belong to or is a part of the Python programming language. So the native data collection data types we will learn in this part of the video course are the set, the tuple, the dictionary, and the list. In addition to these native data storage abstractions, many Python programs use non-native data storage abstractions. For example, in this video course about Python for data handling, we will take a look at loading Pandas data frame objects, which is similar to Excel spreadsheets on steroids. And in other video courses, we will make extensive use of these data frame objects as a fundamental standardized object to store Python data objects in. We will also use native data collections, libraries, and loops to code against Excel workbooks as a part of this course's data handling knowledge. And to make use of all these specialized objects, a data scientist or machine learner needs to have good knowledge about the set, the tuple, the dictionary, and the list. In the next video, in this section of the video course, we will talk about the set data abstraction. which is the most fundamental of Python's native data storage abstractions. And we look forward to see you in the next video. Hello and welcome to this video about Python for data handling. In this video you will learn about the set, which is a Python native data storage abstraction or native Python data structure. The set provides the option to economically store labels and objects that are fixed and not intended to be changed. So let's take a look at the set. The set is a data type for an unordered collection of unique objects that cannot be changed as long as the object is within the set. This means that the set is a collection of unique objects and that it contains objects that can be only one of a kind, and that the stored objects cannot be changed as long as they are contained inside the set. The properties of the sets are that sets are mutable, and that is that new elements can be added after a set has been defined, which means that we can increase the size of the set and add new items to the set whenever we want. There is one exception to this, and that is that the set can be made immutable through Python's frozen set function, and that means that the set will be effectively frozen and cannot be changed. Sets are unordered and don't have index numbers inside the set. So the main use of sets in older Python data science code is to economically store labels connected to codes. The stored set codes can be the locality of telephone numbers, it can be postal code area numbers, it can be state codes, or whatever type of codes you want to use. And this has made sets very useful in the early era of computing when memory and storage space was constrained, whereas current application storage space, often but not always, will grow faster than the need for storage space, for example in cloud computing. And Python creates a set by using curly brackets enclosing objects or items within the set. So now we're going to make an example piece of code to show the set's features. So start up your code editors because we are going to type some code. Alright, having started our Jupyter Labs notebooks, we will start to type some code. And we will begin by creating a set named fruit. And we will fill it with fruits. So we type fruits equals within brackets banana, apple, orange, apple, peach, banana, like this. And we will print the fruit and we will run this code. And as you can see, the set only accepts unique objects. So we have two apple here, but we have only one apple in the set. We have one peach, and we have one peach. We have one orange, and we have one orange. And we have two bananas here, but only one banana in the set. And as you can see, all the duplicates of fruits were automatically removed from the set, and only one instance of each object remains. We can also see that the set is unordered, and that these objects don't have an order other than possible the order which they were entered into the set. However, in this particular set, this order has not been established. So, we can add more fruits to the set with the add function. So we type fruits.add lemon, and we type fruits.add banana, and we print our fruit, and we will show that a new fruit is added and duplicates removed. So let's run this code. And as you can see, the lemon has been added to the set. And the banana was rejected from entering the set because there already was a banana in the set. And we can add multiple items to a set using the update function and list. And we haven't taught you what a list is yet, so you only have to type this code. But before this part of the video section is finished, you will know what a list is. So here you only have to follow and type the code. So we type fruits.update, and here we create a list within brackets, and we add a pear, we add a citrus, and we add a peach. And we print fruits, and we run this code. And as you can see, the pear and the citrus were added to the set, and the peach was not added to the set because we already have a peach. So now we will copy a set, and we can copy sets with the copy function. So we type fruitage equals fruits dot copy, and we print the fruitage, and we run this code. And here we can see that we have an exact copy of our fruits set, and this new copy is named fruitage. And we can remove objects from a set with the remove function. So we type fruitage remove citrus. And we type print fruitage and we run this code. And as we can see, citrus has been removed from the fruitage. Set. And we can clear a set using the clear function. So we type fruits.clear and we print fruits. And this will now be an empty set without items or objects inside. So let's run this code. And here we can see that the fruits is an empty set. And we can delete sets with the delete statement or delete function, we could call it. So we type delete fruits. And we try to print this deleted object. And this will return an error message to us. So we run this code. And boom, here we got an error. The name fruits is not defined. And the set doesn't exist because we have deleted it. And finally, we can loop through a set using a for loop and print the contents of the set. So we type for fruits in fruitage print fruits. So when we run this code, all the fruits inside the set will be printed with a new line for each fruit. So let's run this code. And here we can see that we have peach, banana, apple, orange, pear and lemon. So all right, some of these functions were very new for this video lecture, like the copy, update, for loop, delete and clear statements. And if something is hard to understand or doesn't directly fit, you just continue to the next video lecture and all will be made clear and you can return after finishing all these video lectures in this section of this video course. And I promise you that things here will be very clear and you will feel that this code is very easy and you will feel that this is something that you know and can do easily. So alright, now we have learned a lot about sets and it's time to clear the Jupyter Labs notebook with the edit menu and delete cells command and to prepare for the next part of the video course. So let's do it. We delete cells. We delete cells. We delete cells. We delete cells. like this. Alright, in the next video we will talk about the tuple, and we look forward to see you in the next video. Hello and welcome to this video lecture about Python for data handling. We're excited to have you here, and in this video lecture you will learn about the tuple, which is a Python native data storage abstraction or native Python data structure. The tuple provides us with the option to economically store labels and objects that are fixed and not intended to be changed. Tuples are important to know for data handling purposes, as tuples are used in a lot of data science and machine learning applications, programs, libraries, and code. Now we're going to talk about Python tuples, and tuples are another type of Python set mainly used in older Python data science code as a tool for optimizations, speed enhancements for code, and to some degree as a still preferred return object for some important libraries functions. In this video we include a deep dive into tuples, mainly because a lot of machine learning code, libraries, and in particular older machine learning code may use tuples for optimizations and other tuple properties. And this increases the chance, or rather makes it certain, that any data scientist sooner or later will encounter tuples in their code or libraries. And the properties of tuples are that contents of a tuple are ordered, indexable, and unchangeable, or as you could say, immutable. This means that new items cannot be added to a tuple once it is created, and that the object items inside the tuple cannot be changed or replaced, except through a process of conversion where the tuple is changed into another object and the items are replaced, or if the item is of a changeable type, changed, followed by a conversion back to a tuple object. Structurally, tuples can be considered to be sequences of object items or as unchangeable lists with different properties and capabilities than Python's native lists. And Python creates a tuple through the use of a parenthesis enclosing items within the tuple. You can see some example code on the screen, but we will open JupyterLab's notebook and type some more advanced code. So start up your code editors, because we are going to type some tuple code. Alright, having started JupyterLab's notebook, we start typing some tuple code. And we begin to type tuple 1 equals 1, 2, 3, 4, 5. And we type print tuple 1. And we run this code. And boom, we get a type of error. And this error is because tuple 1 has been misspecified as an int and not as a tuple. And we need to add a comma to change this definition error. And in this case, we will add a 1, 2. So we will change the first line of our code to this code. And we will rerun the code. And this time the code ran as intended. So here we can see that we have a tuple which consists of two ints, which are 1, 2, 3, 4, 5, comma 1. And we can show that we don't really need to have a number, and that the important thing with the tuple is to specify at least 2 positions separated by a comma. So we will rerun the code again, and we obtain a tuple with only 1 int in the first position of the tuple. And we can add more tuples. We type tuple 2 equals hello world. And we type tuple 3 equals hello 1, 2, 3, 4, 5 world. And here we show that tuples can hold arbitrary Python objects. So here we have a tuple with both strings and ints. And we can make a tuple 4. And we give it 2 ints and 2 floats. So here we add floats to a tuple of integers. And we can print tuple 2 plus tuple 3, and we can print tuple 1 plus tuple 4. So let's run this code. And here we can see tuple 2, hello world, and plus tuple 3, hello 1, 2, 3, 4, 5, and world. So now we know that we can add tuples together. And we can create nested tuples or tuples within tuples. And we can create tuples including, for example, declared name, declared integers, or floats, strings, or whatever. So we type float1 equals 3.91, integer 1 equals 9, and tuple 5 equals float1 integer 1 and hello world. So here we have tuple 5, which consists of the named float1, the named integer 1, and an unnamed new tuple, which consists of 2 strings. So we type print tuple 5, and we can print tuple 5 first position. So here we will show that tuples are indexable. So we can refer to tuple 5's internal items by its index, which is indexed from 0 for the first object to the number of objects minus 1. So when we run this code, it will first print the entire tuple 5, and then it will print the first position of tuple 5, the second position of tuple 5, and the third position of tuple 5. So let's run this code. And here we can see that we typed 3.91, 9, hello world. And we typed the float 1 inside tuple 5 by referring to tuple 5's index position. And we typed in 9, which referred to integer 1 at tuple 5's second position. And we typed the two strings hello world as a tuple. And the tuple is shown by the parentheses. So we have a tuple consisting of two strings printed at the third position in tuple 5. And we can access contents of a tuple by referring to the order of items or object items in the tuple. So we can type print tuple 3, and we can type print tuple 3, and here we will refer to tuple 3 and its first position, which is the string hello, and we will refer to the last position of tuple 3, which is position number 2, which is position 3 in tuple 3, and has the string world. So we run this code, and it prints hello world. And now we will use some advanced functions on our tuples. And if you feel that this part of the video lecture is tough, complete the Python for data handling video course and return to this part afterwards. If this part still feels tough, repeat the course once more and return. You will feel that this code has become easy code for you to type and understand as well as develop on your own. And we will begin with the length or len function for tuples. And tuple objects does not have a length function. But we can use a length function on tuple objects anyways. So we can type print tuple length of tuple 2, and we can type the print the length of tuple 4. And we can run this code. And here we can see that we obtain the length 2 and the length 4. And here we can see that tuple 2 has a length of 2 and tuple 4 has a length of 4. And these are the number of objects inside the tuple. So we can type, as we can see, the printed numbers are 2 and 4, the number of items in the tuples. And the tuples can be accessed as ranges using colon operator. So we can type print tuple 4 2 and when we run this code, the two first objects of tuple 4 will be printed. So let's run this code. And here we can see 1 and 4 printed. And in tuple 4, the two first objects are 1 and 4. We can loop tuples, for example, with for loops. So we type for items in tuple 4 items. And these two lines of code will iterate or move over every object in tuple 4 and print every object on a new line. So let's run this code. And here we can see that this for loop first touched object at position 1, which is an integer with the number 1. The second object is an integer with the number 4. The third and fourth are floats. And we can use the index positions, the length function, and loops to create functionality. So we type for position in the range of the length of tuple 3. We print cast as string position plus a white space plus a cast to string tuple 3 tuple-free's position. So this loop will print the position and the value stored or object stored at that position cast as a string for every object in tuple-free. We add a plus and we run this code. And here we can see that tuple-free at position 0 says hello, at position 1 it says 1, 2, 3, 4, 5, and at position 2 it says world. And now we will say that tuple returns from functions and libraries and library functions is one of the main occurrences of tuples in current Python libraries. And the unchangeable property of tuples is the main reason for using tuples as a return item from a function or library. And now we will look at unpacking, which is about unpacking variables from a tuple and presumably a return tuple from a library. And this is very important because many libraries, they return tuples. So when you send your data to the library for some computation, the answer may be returned as a tuple. And these tuples can be designed arbitrarily. So you must look at the description of the library or the function and read the manual to understand what type of tuple is returned, or if it is a tuple that is returned, that is. So in this case, we will use tuple 5, which we have already made in this program, and let it symbolize tuple return from, for example, a library. And we know it has float, an integer, and a tuple inside tuple 5. So we have 3 objects coming from one object, and one of these returned objects inside the tuple 5 is a tuple. So here we have a double nested tuple returned. And now we'll show how to unpack this tuple. So we type float 2, integer 2, and tuple 6 equals tuple 5. So here we have the unpacking process. We know how tuple 5 is designed because we made it ourselves. And we know that it has a float at the first position, an integer at the second position, and a tuple at the third position. So this line of code covers the return and unpacks tuple 5. And we can type print string float2 plus whitespace plus string integer2 plus whitespace plus string tuple 6. And when we run this code, it will print float2, integer2, and tuple 6. So let's run this code. And here we can see that we have a float, an integer, and a tuple. So these variables are now ready for use. And we can continue the unpacking further with tuple 6. So we type string 1, string 2 equals tuple 6. And we print string 1 plus whitespace plus string 2. And let's run this code. And it printed hello world, which is the contents of tuple 6, 2 strings. So alright, now we have learned some deep, practical and useful knowledge on how to use tuples. And now we'll clear the Jupyter Labs notebook with the edit menu and delete cells command and prepare for the next part of this video course. Like this. So, in the next video lecture, you will learn about the very useful dictionary data structure. And we look forward to see you in the next video. Hello and welcome to this video about Python for data handling. In this video you will learn about the dictionary, which is a Python native data storage abstraction. The dictionary provides speed, data key pairings, and the uniqueness of dictionary keys. When using Python and Pandas for data handling, dictionaries are often used to create mappings for name changes to parts of Pandas data frames, or to create input for Pandas data frames. Dictionaries are also frequently used as a tool to create mappings between data items and translations, such as colors in plots and graphics, or labels for classes. Dictionaries are a very useful tool to know for data handling purposes. Now we'll talk about the Python dictionary data type, and the dictionary is a collection that requires data to be stored in key plus value pairs. The dictionaries is a quite modern addition to current programming languages and is mainly used for speed and ensured uniqueness of keys within collections or data sources for data science analysis or machine learning tasks. The enforced uniqueness of keys is a very useful tool for data security in data handling tasks. And the properties of dictionaries are that dictionary items are ordered, changeable, and don't allow duplicates of dictionary keys. A dictionary key is restricted to strings, numbers, or tuples with arbitrary values as long as they are immutable. And dictionaries are indexed by their keys and may have any current Python object as data value. So now let's make our example piece of code to show dictionary code, and we will make a fictitious mail catalog where we will use a person's fictitious name as the key and a fictitious mail address as data object. So let's start up our code editors because we are going to type some code. Alright, having started our code editors, we will type a string object mail catalog code example. And we'll begin to type mailcat equals curly brackets, and the first key is Joe, and its data value, which will be a mail address, is joe@gmail.com, and the second key is anand, at anand.anand@aol.com, and the third key will be Lisa, at lisa.gmx.com. And we will print this mail catalog. So we type print mailcat and we run this code. And here we can see that we have a dictionary within curly brackets, and that the first key is Joe, and its data value is a string with an email address, which is joe.joe@gmail.com, and the second key is anand, and its data value or string, which is a email address, is anand.anand@americaonline.com, and the third key is Lisa, and the data value is the email address lisa@gmx.com. And to add an instance, for example Mohammed, to the dictionary, all we need to do is type mailcat Mohammed equals Mohammed.gmail.com. So this line of code will add the key Mohammed to our dictionary with the data value string email address mohammed.gmail.com. And to show that Mohammed has been added, we type print mailcat. And we run this code. And as you can see, Mohammed has been added to the mail catalog. And we can type, as we can see from this code, a dictionary is created with a name, the equality sign, and two curly brackets. So name of the dictionary equals curly brackets will create a dictionary or declare its existence with a name. And we learned how to add another string instance to the dictionary. And now we will add an integer key string instance to the mail cat dictionary to show the versatility of a Python dictionary. So let's type mailcat 5 equals, this is a string value with an integer key. And we print mailcat. And we will run this code. And as you can see, the integer 5 is now a key in this dictionary, and it has a string value, which has nothing to do with email addresses. And this shows that you have versatility with the keys, and that you have extreme versatility with the values. And this is something to think about. Now we will show some ways to address and print the dictionary keys and items. For example, we can type print mailcat keys, and we run this code. And here we can see a list of the keys in the dictionary. And if we type print mailcat dot values and we run this code, we will obtain a similar list of the data values in the dictionary. And if we type print mailcat.items, this will print the key value pairs in the dictionary. So let's run this code. And what we obtain here is a list of tuples. And every tuple is the key and the corresponding data value. So this is very useful to know, because a lot of advanced machine learning programs uses these types of dictionary and tuples to move data around. So understanding how this works can be very useful when you reach the next stage within machine learning programs and competencies. So now we will type some more code, and we will print the value of a given key. So we type print mailcat, and for example we could take the key Lisa for this code. So we run this code and we obtain the data value for the key Lisa. And similarly, if we type print mailcat 5 and run this code, we will receive the data value for the key 5. So let's run this code. And it returned the data value for the key 5. And there are some other versions of this, so we can type print mailcat .get the key Lisa, and this will return the value for the key in the dictionary. But if the value is not found, a default value will be returned. For example, a non-object. So let's run this code. And in this case, the dictionary had a data value to return, and it is lisa@gmx.com. But in some cases, one can easily see that an existing key could have a non-existent value or object stored. And if that is the case, this function is very useful. One property which is important to note is that key names must be correctly specified with upper case characters or lower case characters. Wherever appropriate. And if we want to change the data value of a key in the dictionary, we can make the change with this code. So we type mailcat Joe equals Joe2 @gmail.com. And to show that this has been executed correctly, we type print mailcat, and we run this code. And here we can see that for the key Joe, we have changed the data value from joe.joe@gmail.com to joe2.joe2@gmail.com. And if we want to delete a key value pair, it can be done with this code. So we type delete mailcat 5 and we print our mail catalog. And we run this code. And as you can see, the integer key 5 with its data value has been removed from our dictionary. So now it is time for some more advanced dictionary functions. If they feel complex at this stage, return after completing the Python and Pandas sections. If these if the following code still feels complex, return again after completing the other parts of this video course. And we can say that all will be clear with some practice, and that exercise makes the master or mastery. So we will start with the length function. And this function tells us the number of key value pairs in a dictionary, or the number of items, elements, or key value instances in the dictionary. So we type print the length of our mail catalog. And we run this code. And as we can see, we have 4 instances. We have 1 here, we have 1 here, 2, 3, and 4. And this function is very useful if we need to iterate over the dictionary. And we also have the string function, which creates a string of our dictionary. And this may be useful in some text mining applications. So let's type print string male cat. And this will return and print the male cat dictionary as a single string within curly brackets. So let's run this code. And this is now a string object. And this means that we can treat it as a string. And this is a very useful property, which is easy to handle. So now we will show some loops. And this loop iterates through all the keys in a dictionary and prints each key on a new line. So we type for M in male cat, print M. And we run this code. And here we can see that it iterated through the list of keys and printed each key on a new line. And this is very useful because with this type of iterator you can extract and operate on all the keys in a dictionary. And this more advanced loop iterates through all key value pairs in our dictionary and prints each key value on a new line. So we type for K and V, key and value, in malecat.items, print K and V. And we need to make a little change like this. And we run this code. And here we can see the key, the data value, the key, the data value, and so on. And this particular function is extremely useful when operating on very advanced machine learning algorithms. It is frequently used in network-based graphs and similar very advanced items. So this is a very important loop for a dictionary to understand and use. And knowing this, how to use this for loop and dictionary items function will make a lot of advanced code much easier to understand. So now we will show how to delete all elements in a dictionary. So we type malecat.clear and this code deletes all elements in a dictionary, in our dictionary. And to check that the male cat is indeed deleted, we type print male cat. So let's run this code. And we received empty brackets. And this means that the male cat dictionary still exists, but that it is empty of keys and values. And now we will show how to delete the dictionary. So we type delete male cat and print male cat. And this will return an error because there is no male cat after deleting it. So let's run this code. And here we can see that the name male cat is not defined because it was deleted. So now we will clear the Jupyter Labs notebook with the edit menu and the delete cells command and prepare for the next part of this video course. So we will delete the cells. Like this. And in the next video we will talk about the list data abstraction. And we look forward to see you in the next video. Hello and welcome to this video about Python for data handling. In this video you will learn about the list, which is a Python native data storage abstraction and native data structure. The list provides Python users with a data storage solution which is versatile, extendable, updatable, changeable, general, and a one for almost all situations solution for most types of data storage. Some users even consider the lists or modified lists to be the solution for any and all situations. The list is a very common data storage tool and is very useful to know for data handling purposes. So now we're going to talk about the Python list data type. And for data science and machine learning purposes, the Python list data type is the most useful, versatile, and general data storage type available. The list data type is a container for items that are ordered, changeable, and allows to duplicate items or values. In practice, this means that with a list we can update, delete, remove, or add items to the list, or even add copies of existing items in a list to the same or another list after the list has been created. And this is a very useful property of the list, and the list can also accept any type of Python objects. So a list can contain integers, strings, arbitrary user-created objects, tuples, sets, other lists, or whatever objects you want to have in the list at the same time. The object types don't matter to the list object. And this means that the Python list is so general that the stored objects don't need to be of the same type. And this property of the Python list has consequences as compared to some lists in other languages. And this consequently means that when you use list in practice, you must either control whatever object your program put into the list to have both control of the objects and the knowledge of the object type, or if you don't have that control or knowledge, you must check what type of object you get from the list when you ask for the object or an object at a position in the list. Because when you ask a Python list for its contents, you will receive the contents, and sometimes it may be an integer, and sometimes it may be a string, and sometimes it may be a float, or an arbitrary user-created object. And this description shows the most important properties of the list's flexibility, and the need to control the list and its objects either at input time or at output time. And list items are indexed with integer numbers, and the first item in a list always has the index number 0, the second 1, the third 2, and so on. And lists has the advantage that we can address a position in the list by referring to an integer number. So, Python creates lists through items separated by commas within brackets, and now we're going to look at some example code. So start up your code editors because we're going to type some Python list code. All right, having started our Jupyter Labs notebook, we can start to type our first list equals within brackets 7, 4, 3, 9, and bananas. And we can print string our first list plus string our first list 2 plus white space plus string our first list 4. And this code will print 93 bananas and string list index instructs Python to read the ints as strings. This is one basic type of control of list output. So let's run this code. And the first thing our code did was that it created a list, which we named our first list, and it contains 4 integers and a string, bananas. And what we did is that we choose to print position 3 in the string, and you remember 0, 1, 2, 3. So we print first position 3, which is a 9, and then we printed position 2, which is a 3. And then we created a white space using Python's native string functions, and we printed a string cast to a string. So what the string casting does is that it instructs Python to read our integers or whatever we have inside the parentheses as a string. And this is very useful when you create complex print commands. And now we will show that a list may be changed by assignment. So we type a list may be changed by assignment. So let's make an assignment. Our first list 2 equals our first list 1 equals 2. And we print our first list. And this will print 7, 2, 3, 9 bananas. So let's run this code. And it printed 7, 2, 3, 9 bananas. And here you can see differences between different ways of printing commands. For here we printed an entire list and we have the brackets, and in the earlier print command we printed only values or objects from inside the list. New items or objects may be added with the append method or function. So we type our first list append apples, and we print our first list. And this will print 7, 2, 3, 9 bananas and apples within brackets. So let's run this code. And it printed 7, 2, 3, 9 bananas and apples. So there are two main functions or methods for removing items or objects from a list: the delete statement and the remove method. So we type delete our first list 4, and we print our first list, and this will print 7, 2, 3, 9 apples. And we type our first list remove, and we print our first list, and this will print 7, 2, 3, 9. So let's run this code. And as you can see, Python printed two lists, one with apples and one without apples. Because in the first line of code, we removed the bananas, and in the second line of list code, we removed the apples. So now we have a list with only integers. And we can add lists together. Python lists can be added together using either the plus operator or the extend or append functions or methods. So we type our second list equals 1, 4, 5, 6, 8. And we type our third list equals our first list plus our second list. And we print our third list, and this will print 7, 2, 3, 9, 1, 4, 5, 6, 8. And we can type our first list dot append our third list and we can print our first list, and this will print 7, 2, 3, 9, and 7, 2, 3, 9, 1, 4, 5, 6, 8. And we can type our third list, extend our second list. And we can print our third list. And this will print 7, 2, 3, 9, 1, 4, 5, 6, 8, 1, 4, 5, 6, 8. And we can print the length of our third list, and we can print the length of our first list. And this will type 14, and this will type 5. So let's run this code. And here we can see the differences between the commands. The plus operator simply takes the two lists and jam them together. The first list first and the second list thereafter. And the append command is a bit different when you use this list because our first list obtains a list and not a large number of positions of integers from the append method. So this is important to think about. And also when you cut and paste, for example, numbers or code, because it is very simple that these brackets just follow in a cut and paste, for example, because they are in the right place and everything looks natural. But when you cut and paste them into the next list, you get a list of lists. And a list of lists is also a very useful construct. And the extend command, to some degree, acts as the plus operator. So you have the third list, and it is extended by the second list. And the length function simply calculates the number of functions. And this is very interesting when we have a list of lists. Because despite the output, when you print the list of lists, the length of the list which you ask for is in this case only 5, whereas you have 14 positions in the print command. So this is also a very important thing to keep in mind and to keep track on when considering lists, and in particular lists of lists. Or when we consider, for example, text mining and network graphs, we sometimes have lists of lists of lists of lists, which are quite unwieldy sometimes. So now we're going to sort lists. So we will sort our third list. And we will begin by printing our third list. And we will sort it. So we type our third list dot sort. And we print our third list. And this will print 7, 2, 3, 9, 1, 4, 5, 6, 8, 1, 4, 5, 6, 8. And this will print 1, 1, 2, 3, 4, 4, 5, 5, 6, 6, 7, 8, 8, and 9. So let's run this code. And as you can see, our third list has been sorted based on the value of the integers in the list, from the smallest or lowest integer to the highest or largest integer. And with lists, we can also address ranges of the list. So we can type print our third list 1, 2, 4, and this will print 1, 2, 3, and we can print our third list 3, and this will print 1, 1, 2, and we can print our third list 12, and this will print 8 and 9. So let's run this code. And here you can see various ways to address the list. So in the first case, we type 1, 2, 3, and this is these 3. In the second, we type these 3, and in the third, we type these 2. Or rather, we printed these 2. So Now we will move objects from one list to another list with the pop function. So we type our third list dot append. So we will use the append method, and we type our third list dot we type our first list dot pop one. And we print our third list. And we run this code. And here we can see that the value 2 from the second position of the first list has been moved from the first list to the last position of the third list. And the append function will always add new objects to the last position of a list. And now we will move objects from one list to a specified position of another list. Using the insert and pop functions. So we type our third list dot insert from our first list dot pop 0. And here we will print our third list. And we can also print our first list. So let's run this code. And here you can see that the first object from our first list has been moved from our first list to our third list. And we have placed it at the third position, which is integer position 2. So now we're going to talk some about how to check object types. So we type use Python native functions, type or is instance to check object types if you don't control list input or list contents. It is a good practice to always do this in real application code. And this is important to remember because for pedagogic purposes, we will not write all this necessary code every time we write code because we must make code simple for pedagogic purposes. We can't do this every time we use a list, although we might be doing type checking if we had a real word application, for example, with images or sounds or movies or whatever occupying positions in the list. So this is very important, and we will show basic functions for this with the assumption of having a list with only integers or wanting such a list with integer contents. Basic functions only. So all right, let's type string test equals 1, and we can type string test2 equals 1, and we type our third list dot append string test1, and we print our third list. And now we're going to use a if statement. We type if type, we use the type function, our third list in the last position is not an int, we will print the object is not an integer, and we will delete our third list in the last position. Else, we will print the object is an integer. And we will print our third list. And we will also use the isInstance function. So we type if isInstance string test2 int our third list append string test2, and we print our third list. So the first thing we do is that we'll create a string with the string value of 1. So we have a string describing a integer 1, which is not an integer but a string. And we have an integer with the value 1. And the first thing we do is that we add this string integer to our list of integers, and we print the list. And as we have put this string integer at the last position of the list, we also test the type of this string integer at the last position in our third list. So we ask if it is not an integer. So we test for an integer, and if it's not an integer, we continue with this function and delete this object which is not an integer from the list. And if it is a list, we will print the object is an integer. And we will run this code and see what happens. And similarly with the real int, we will use a function to check that it is an int before adding it to our third list. So if this int would not be an int, it would not be added to our list of integers. And these are two very simple checks, which in a basic ways show how to use state-of-the-art type checking to check that you have the right objects. So let's run this code. And here we can first see that the string integer was added to our list of integers. It was found that the object is not an integer, and it was removed, as we can see from this printing of the list. And for the isInstance function test, we can see that our integer was found to be an integer and added to the list. So all right, this has been an exciting video lecture about Python lists, and now you know Python native data collections for basic data handling and have had a great, possibly one of the best introductions available to the very useful Python lists. In the next part of this video section, you will learn about loops, control logic, and functions. And we look forward to see you in the next video. Hello and welcome to this video about Python for data handling. We're excited to have you here, and in this video you will learn about Python native data transformers and functions. These data transformers and functions are necessary tools for any data scientist or machine learner, as data transformers and functions are necessary to manipulate, transform, analyze, or synthesize information from data. The fundamental basic Python tools you will learn in this part of the video section are Python native loops, such as the while loop and the for loop. You will learn about Python's logic and Boolean operators and learn to use them with if then else statements to create conditional code branching. And you will learn how to design and create your own user-defined functions in Python. So now we're going to talk about what data transformers and functions are. And data transformers and functions are tools used to change or to transform variables or data objects. Data transformers and functions can be used to compute values, to change values and variables, to create objects, variables, graphics, and to control logic and program execution. These tools are necessary for data science and machine learning because with these tools we can create information from data, and this information may be used to analyze data, to group data, or to synthesize the information from data within data science, or to automate machines or to create artificial intelligence capabilities within machine learning and artificial intelligence. So, in this part of the video course, you will learn about the fundamental Python loops, such as the while loop and the for loop. You will learn about some Python Boolean and logic operators, and you will learn how to use them with if then else statements, so-called conditional code branching. And we will take a look at Python user-defined functions, and we will push your level forward a bit so you will be able to define your own basic Python functions after completing this part of the Python for data handling section of the video course. So, in the next video, you will learn about the while loop, which has some use in data science algorithms and is an absolute necessity for machine learning as a tool for program or AI persistence. And we look forward to see you in the next video. Hello and welcome to this video about Python for data handling. We're excited to have you here, and in this video you will learn about Python's native while loop, which is fundamental to machine learning and artificial intelligence and has some use in data science. Now we'll talk some about the while loop. And the while loop is a Python native function which iteratively on a step-by-step basis moves through the program or a data storage collection. The while loop is a special case of the for loop, and the while loop's code is kept iterating or repeating itself and its code until a specified logic condition becomes false. And the while loop is fundamental to machine learning and artificial intelligence in terms of providing persistence to programs and applications, as it provides continuous operations or execution of a program until a condition is met, for example, that the user pushes a particular button, such as an on-off button, or that the machine detects a particular circumstance. For example, it could be sunrise, it could be weather, it could be rain, the wind is blowing, motion, or anything that the machine can measure and has programmed code to handle. It could be that a detector finds something, that a laser beam is broken, pixels moving on a screen, sound, recorded sound, or something similar. It is for the data scientist or machine learner to define the logic condition for the while loop, and while the while loop only purpose is to execute statement within the loop until the while loop's condition for continuing becomes false. So we will begin to create this example while loop and use an integer loop counter variable and a statement which states that while the loop counter is less than our specified integer value, the while loop will continue to repeat itself. Every time the while loop repeats itself, the loop counter will increase with 1 and the print function will print the value of the loop counter. So the while loop will continue to repeat itself until the loop counter variable becomes larger than the particular value which we have specified as the condition for falseness of the continuing execution of the while loop. One double-sided issue and useful property of the while loops are that a while loop may continue to execute endlessly unless we have some terminal property, rule, or shutdown function included in the while loop. And this is an issue because while loops may freeze the execution of a program if it is not sufficiently controlled. And this property is also an absolutely necessary property for automated machinery, machine learning, robotics, and artificial intelligence, because this property provides the ability to continuously run a program. And within data science, the while loop has some use for algorithms. So now we'll type some while loop code in the Jupyter Labs notebook. So start up your code editors because we're going to type some code. All right, having started our Jupyter Labs notebook, we will type some while loop code. And we will begin to define an integer loop counter. We call it loop counter. We set it to 0. And we type this integer variable keeps track on the number of repetitions or iterations of the while loop. And we type while loop counter is less than 10, loop counter equals loop counter plus 1. And we print the loop counter and finally we print This is the final value of the loop counter integer variable. Plus string loop counter. Like this. And let's run this code and see what it does. So we run this code. And as you can see, loop counter was 0. 1 was added to it on the first repetition of this while loop. And we printed 1. And in the final iteration, because every time we repeated this loop, the loop counter variable had 1 added to it. And the value in the final repetition of the while loop was 9, because it entered the loop with this condition less than 10 being true as 9. 1 was added to it, it became 10, and it was printed as 10. And on the next iteration, 10 is not less than 10, so the statement becomes false, and this loop terminated. So now we're going to talk about while loop, infinite while loops, and break statements. And we can say that a while loop, is a great tool for keeping a program running indefinitely forever. Loops may also lock a program in execution mode. And one way to handle this is to insert break statements. And this while loop creates a possible infinity loop without break exits from the loop, without our break exits from the loop. And here we must say that many programmers detest break statements, and this is in particularly true when they have complex loops, because it is very hard to keep track on multiple exits from these loops. So according to the hardest standards of coding on this type of loops, you should only have one exit from a loop. And here we have, for example, 2 exits in the loop we will type now. So we type loop counter 2 equals 10. And we type while loop counter 2 is less than 5. Loop counter 2 equals loop counter 2 plus 1. and we print our loop counter 2. And here we add an if statement. We type if loop counter 2 equals 20, array. And we print this is the final value of the loop counter 2 integer variable. Plus string loop counter 2. And we change that condition like this. And as you can see in this case, this statement will never become false because we have defined loop counter 2 as larger than 5 and always increasing. And this means that this logic statement will never be false under the conditions which we have stated in this code example. And that is why we have the break statement which will execute when the loop counter 2 becomes 20. So let's run this code. And here we can see that the loop counter 10 was increased by 1 to 11 on the first iteration, and that the final value was 20. And the break statement just terminates the loop completely when they are executed. And as you can see from this example, it is very easy to create while loops that keep iterating or repeating forever or for a very long time, especially if complex conditions for the falseness of the loop condition is used. And it is considered Pythonic behavior to not create hard to understand or analyze logical statements, such as a while logic statement 1 is true and logic statement 2 is true and a large number of other logic statements are true and logic statement number n is true. So we should not create complex logic statements, even though we could. So having complex logic statements is not a sign of a good programmer. Code should be kept simple and efficient and Pythonic. So now we will show an algorithmic way to use the while loop with Python lists. So we type list tested equals an empty list, and we type list untested equals a list of animals. We can have a cat, we can have a dog, we can have a horse, we can have a bull, and we can have a cow. Like this. And we can create a while loop for executing tests on these animals. And when they have been tested, we move the animal from the list of untested to the list of tested. So we type while the length of the list of untested is larger than 0. We print testing a plus string list tested at position 0. And we append from the list of tested, from the list of untested, and we use the pop command, and we pop the tested position. And finally, we type print all these animals have been tested. And we print list of the tested. And we use a separator with a comma and a white space. So what happens when we run this code is that we have two collections with lists, Python native lists, and we have a while loop which will execute until the list of untested animals are empty. So effectively it will execute until this list becomes an empty list, which has the length of 0. And every time we test one of these animals from the left to the right, we will type testing a cat, dog, horse, and so on. And after printing this string, we will move the tested animal into the list or collection of tested animals. Here we make a little change. So let's run this code. And here we can see that first we tested the cat, then we tested the dog, the horse, the bull, and the cow. And finally, we printed a list of all the animals we had tested. And this shows that all the animals were moved into the list of the tested. So there we have tested the cat, the dog, the horse, the bull, and the cow. And as you can see, this is very useful when you, for example, put model parameters into lists of the tested and untested, and you can move a lot of things around. It could be neural network parameters, it could be regression parameters, it could be cluster units, it could be a lot of things that you move between different parts of collections. So it could be variables, it could be links, it could be network links. It is only your imagination that puts a limit on what you can create with these tools. So all right, now we have shown you the while loop and some useful and practical ways to use it. In the next video, you will learn to use the extremely useful for loop. And we look forward to see you in the next video. Hello and welcome to this video about Python for data handling. We're excited to have you here, and in this video we will talk about Python's native for loop, which is fundamental to data science and machine learning. So now we will talk about the for loop. And the for loop executes statements for each item in a defined range or object collection, such as a Python native dictionary or list. This means that the basic for loop walks through each item or element or object in the collection and executes its statements or its blocks of codes for every element in the range or collection. The for loop is often the most used native function within data science and machine learning. It is effectively necessary even for the most basic functions such as the calculation of a mean or an average for a collection, as the calculation of the total and the divisor requires each object in the collection to be touched at least twice by the algorithm to calculate the total sum of the values of the objects and to calculate the total number of objects, because you use the total value of all the objects or the sum and divide it with the total number of objects. And this means that algorithms need to touch every object at least twice in order to execute the calculation of an average or a mean. So here we have an example of a loop code that adds 1 to each integer value of a Python list. And now we'll type some code in the Jupyter Labs notebook to start up your code editors, because we're going to type some for loop code. Alright, having started our code editors, we will go back to our last example and we will take our third list, which is a list with a set of integer numbers is sorted, and we will use a for loop with code to add 1 to every integer in the list. We start typing our third list. So let's type our third list equals like this. And we type our first for loop for item in range of the length of our third list, our third list item equals our third list item plus 1. And we print our third list. And this will print 2, 2, 3, 4, 5, 6, 6, 7, 7, 8, 9, 9, and 10. And it will also give us the brackets for a list. So let's run this code. 2, 2, 3, 4, 5, and so on. And we can write this simpler. So we can type, there is a way to write this simpler. And we type our third list equals item plus 1 for item in our third list. And we can type print our third list. And this will print 3, 3, 4, 5, 6, 7, 7, 8, 8, 9, 10, 10, 11. All right. So let's run this code. As you can see, 3, 3, 4, 5, 6, 7, 7, 8, 8, 9, 10, and so on. And these for loops can also be used with other operators than plus or add. For example, multiplication. So we type for item in range of length of our third list item equals our third list item times 1000. And we print our third list. So let's run this code. And this code runs on every item in the list and multiplies it with 1000. And as you can see, every item in the list has been multiplied with 1000. So we can type for loops can be useful for many types of tasks. For example, lists. So we can make a list of animals, and you probably recognize this list of animals. Type cat, dog, horse, bull, and cow. And we can type for animal in list of animals print animal. To create a bit of space. So let's run this code. And as you can see, we had our list of animals printed. So now we're going to show the very useful enumerate function. So we type for loops can be used with Python's very powerful enumerate function to, for example, enumerate objects in a list. So we type for num animal in enumerate list animals, and we will print num and animal. And we can type that this can be a useful trick when creating a dictionary from a list, considering the need for unique keys to create the dictionary. We can also type that this is also useful for many data operations where enumerations are necessary. So let's run this code. And here you can see that we have enumerated the cat at the first position as 0, dog at the first, and so on. And these would be unique keys regardless of how many cats and dogs and horses we had in this list. So this is a very, very useful trick that will solve or aid you in solving a great many issues or create solutions to many data science and machine learning data analytics. So for loops can be used on ranges or parts of lists or collections. So we can, for example, use list slicing with for loop. So we can type for animal in list of animals, and we can define the list of animals as being smaller than it really is. For example, the 2 first animals. So we can print the animal. And we can run this code and it will print the 2 first animals in our list. So let's run this code. And we have the cat and the dog. So now we know that list slicing works with for loops and lists. And we can use ranges, the length function, and the step part of the range function. And for example, choose only every other animal on the list. So we can type for animal in range of, we can say 1, and length of the list animals. We can take every other animal and we can print the list of animals and the animal. So let's run this code. And we can see that we pointed at from position 1, which is the dog, and every other. So we jumped over the horse and printed the bull, and we jumped over the cow. And had the list been longer and had the parakeet as item 5, we would have printed it. So all right, now we have learned to use the extremely common and useful for loop. In the next video, you will learn about some of the logic operators and combine this with, inter alia, the for loops of this video lecture and conditional code branching. And we look forward to see you in the next video. Hello and welcome to this video about Python for data handling. We're excited to have you here, and in this video you will learn about Python's native logic operators and code branching through if-else statements, which are fundamental to data science and machine learning. The logic operators you will learn to use are the basic Boolean operators and OR operators and simple operators such as the less than, equals, or larger than x operators, and you will learn to use if-else statements effectively. Now we'll talk some about loops and logic operators and code branching. And while there is a large family of logic operators, they all have something in common, and that is that you ask them a question with a statement, and if that statement is true, they return true, and if not, they return false. And these logical questions can be used with conditionally branching code, for example, if-else statements to divide the execution of code into different code blocks depending on if a statement is true or false. This ability to use different code blocks results in the capability to perform different actions depending on a Boolean condition. So now we have two main concepts, the logic operators with Boolean logic and the structures for conditionally branching code. So we begin to talk about the Boolean logic. So we have, for example, requirements, and we have the requirements for truth. So for example, we have a logic statement which must be true and a logic statement which must be false. And if we put the AND Boolean logic between them, both must be true. And if we put, for example, logic statement true or logic statement 2 is true, 1 must be true. And we have the numeric questions, which we use to formulate these statements, which we will use Boolean logic on. And we have some examples. We have the less than sign, so we can say that one number is less than another number. And if that is true, we get a true from our Boolean logic. And otherwise, we get a false. And similarly, we can ask a question based on two numbers and ask if a number is less than or equals the other number. We can ask if two numbers are equal to each other, or for example, two strings are equals to each other. And equals is usually value based. So what we check is if, for example, if two ints have the same value, or if two strings have the same structure of characters. And we can test if a number is larger than another number, and we can test if a number is larger than or equals another number. And we can test if a number or structure is not equal to another structure or number. And this is one of the most Pythonic ways of implementing a not equals or not Boolean logic statements. And preferably a not equals should compare against a single value construct or an existence such as not in a list or a collection. So we can use this not equals logic in the most Pythonic way when we ask, for example, if a number is not equal to another number, or if a object is not in a list or a collection. Because this not equals operator, it can very quickly be used to create advanced logic which few persons are able to follow. And this is the reason why we say that the simple things are Pythonic. So we also have the conditional execution, and the way we will look at this is through the branching code. And the first condition is the if condition. So what we do is that we ask if a condition is true. And if the condition is true, we will execute the code block that belongs to the if statement. And we can also ask an else if condition is true, and these are mutually exclusive from each other. So we can make a large list of else if statements if we want, but they must be mutually exclusive with the first if statement. And these else if logical conditions are optional, so you don't have to use them if you don't want to. And you can use several if conditions also, but you must know that they may execute linearly and may not be mutually exclusive with each other. And finally, we have, for example, an else catch, which is a catch-all type of option, which we can use in these statements. So if none of these if or else if statements are true, we can use a else statement to catch everything that has not been caught by another condition. So with these tools, we can execute stepwise or chain comparisons. For example, we can say that the integer y1 is larger than x, and that x is larger than y2. And this corresponds to a Boolean logic question where y1 is larger than x, and logic and the variable x is larger than the variable y1. And we can execute type and value based is comparisons using the equals operators. We can ask if x is equal to y1. And equals here means that, for example, the integer variables both have the same value, which could be 10. So 10 equals 10, true or false. That's what we ask in this statement. And another type of comparison is the identity-based comparisons, which we also can execute with the is operator. So we can ask if x is y1. And this is true if x and y1 is the same Python object, or if x references the y1 object, which is much more common. So now we're going to type some code to start up your code editors. All right, having started our code editors or Jupyter Labs notebooks, we will start by recreating our third list of integers from the for loop code example, and we will recode it into a list of strings named our fourth list using logic operators and conditionally branching code to divide the execution of code. Now we'll start recreating our third list. So we type our third list equals 3, 3, 4, 5, 6, 6, 7, 7, 8, 8, 9, 10, 10, 11. And we type for item in range of length of our third list. Our third list item equals our third list item times 1000. And we print. Our third list. So let's run this code. And as you can see, our third list has been recreated. And now we'll recode our third list into our fourth list using a for loop, logic operators, and conditionally branching code. So we type our fourth list is an empty list. So we create our fourth list. And we type for item in range of the length of our third list if our third list item is larger than 7000, our fourth list will append the string high. Else if our third list item is less than or equals to 7000 and our third list item is larger than or equals 5000. Like that. Our fourth list append the string medium. Else our fourth list append the string low. So what this code does is that the for loop iterates over every item in our third list. So it's going to visit every item here. And the first if statement will ask if the item is larger than 7000. And this is true for 8,000, 9,000, 10,000, and 11,000. And if that happens, our new empty list on the first iteration of this loop will append a high. And if this item value is lower than 7,000, the conditionally branching code will ask through the else if statement or elif statement if the value is equals to 7,000 or lower than 7,000, and it is an and operator here, and if this item is larger than or equals to 5,000. So both these must be true. And for example, if you have 5,000, this is true, and 5,000 is also lower than 7,000, so it's also true here. So for 5,000, it is true for both. So 5,000, it is a medium. And similarly for 6,000 and for 7,000, because we have an equals to 7,000 here. But for example, 3,000 and 4,000, this is not true, but false. And then we have the else or catch all branch of the code. So for 3,000 and 4,000, our for list will append low. And we can print the result into a table using another loop. And note that in this example, both lists have the same length. So we type for item in range of length of our third list print string our third list item plus \t, which create a tab, plus string our fourth list item. And let's run this code. And we got two columns just as expected. And as we can see, we have values and we have their corresponding string. And together these two columns form a table. So what we have done now is that we have used a conditionally branching code in the if then else, if or else if statement with logic operators and less than or equal statements. And we have combined this with a for loop to perform a task which is very common within data science. And it is to create classes or to record numbers into classes or categories. So this is a very useful operation to understand the fundamental mathematics of, although there are prepared functions to do this in most data science and machine learning libraries. So now we'll use the conditional branching and logic operators to create some basic statistics. So let's type some basic descriptive statistics. So we type list of unique categories equals an empty list. And we can create a no operation counter. And we put it to 0. And we can type for item in our sort list if item not in our list of unique categories list unique categories append item. And we can print item plus number in category plus string our for list dot count item. And else no operation counter equals no operation counter plus 1. So what we have here is an empty list which will describe our unique categories. We have a no operation counter which we intend to add 1 to every time we don't do anything at all in this program, which is a no operation. And we begin by using the for loop on our sort list. And we only ask with one if statement, if the item, which is a string, is not in our list of unique categories, we will add the item to our list of unique categories. So we will append the item to the list. And if we discover a new item which we don't have in our list of unique categories, we will print the item plus the number in our categories, and we will count every occurrence of this item inside our sort list. And else, that is, if the item is in the list of unique categories, we will do nothing, but add to the no operation counter plus 1. So this is what this code executes. And now we'll print the number of unique categories are length of our list of unique categories, and we will print the number of no operation passes are string no operation counter. And we will print the unique categories are and we will print the list of unique categories. So let's run this code. And here we can see that our code perfectly counts the number of low, medium, and high numbers. So we have 6 high, we have 5 medium, and we have 3 low. 3, 5, 6. And the number of unique categories are 3, low, high, and medium. And the number of new operation passes are 11. And this is related to the number of items, which is 14. And unique categories are low, medium, and high. So now we have learned to create some descriptive statistics from a list of classes created from a list of integer numbers. And now we'll create a dictionary version of this. So we type descriptive statistics equals, and for word in our for list, if word in descriptive statistics, descriptive statistic word plus equals 1, else descriptive statistics word equals 1. And we can print a sorted output. So we type for word in sorted descriptive statistics key equals descriptive statistics dot get. And we print descriptive statistics word and word. And this code creates a dictionary. And for every word in our for list, if the word is in descriptive statistics calculates it as +1. And if the word is not in our descriptive statistics, we throw the word into the descriptive statistics and give it the value 1. So what this does is that for every unique word in our for list, we get the word as a key and the number of occurrences as a value. So every time a word is found, the integer value 1 is added to the value of the key of the word. And finally, we sort this dictionary based on the keys, and we print the key plus value in tuples. So let's run this code. And here we can see that we have the number value of the key value pair, and we have it sorted from the lowest to the highest. So here we know that we have 3 occurrences of low, 5 of medium, and 6 of high. And which version of this is the best is a debate, and it depends on the size of the lists, the number of unique classes, and the purpose of the operation. There are also plenty of pre-designed statistics functions available in Python and libraries, and the code we showed in this video lecture is mainly intended to be pedagogic and to be very useful when you need to do something that is not covered or easily accessible in pre-designed library functions. So knowing these operations at the detailed level gives you the power to edit and tailor functions at a detailed level, and this may be very useful to know. So now we'll continue to the next part of this section of the video course, and in the next video you will learn how to create your own user-defined functions. And we look forward to see you in the next video. Hello and welcome to this video about Python for data handling. We're excited to have you here, and in this video you will learn about Python's defined functions and learn some fundamental theory to create your own functions using Python, as well as some theory about how to organize code using Python's functions. Defined functions are Python's way of organizing, modularizing, and reusing code efficiently. Functions present one way to simplify coding, one way to prevent the same code from being written many times over, and Python's functions also create code blocks that are easier to read and easier to understand through a common coding structure standard. In practice, this results in that our functions makes us able to write more readable code. In large programs, the use of functions results in an ability to decrease the code mass considerably, and that is to write a lower number of lines of code and to have a lower number of lines of code to maintain. Python's functions gives us the ability to test parts of the code individually and independently of the rest of the code, and this is very useful as we can make sure that different parts of the code function as intended without having to test an enormous amount of code every time. Combined with Python's dynamic typing, this is an extremely powerful and time-saving feature. Python's functions also gives us an interface which makes it very easy to copy or import functions between programs rather than cutting or pasting code blocks between programs. So, these are the properties that make Python's functions so very useful to data scientists and machine learners. In this section of the video course, we have already used many of Python's native functions. So we have touched the concepts of functions earlier. For example, we have used the print function, the length function, and the range function. In the next video, we will show you how to make your own functions through examples of functions that calculate the mean of a list of values and return a float as the answer or return value. And we will show you how to make functions with some basic protections against bad code or bad data. And we will show you how to make functions of useful code, which we have used in earlier videos. So we will teach you how to use the code, which you have already learned, and how to transform it into a function for use. And we will teach you how to generalize these functions to near advanced uneven, multi-type, and two-dimensional lists of lists. And we look forward to see you in the next video. Hello and welcome to this video about Python for data handling. We're excited to have you here, and in this video you will learn how to code your own defined Python functions. We will begin with a very basic function for calculating means, and we will teach you how to code some basic protections for your functions against bad code and bad data. You will learn how to make functions of useful code, which we have used in earlier Python videos, and we'll teach you how to generalize and reuse these functions to very near to be advanced, uneven multi-type, and two-dimensional lists of lists. So start up your code editors, because we're going to type some code. All right, having started our Utilabs notebooks, we will start by recreating our third list from the earlier examples. So we type our third list equals 3, 4, 5, 6, 6, 7, 7, 8, 8, 9, 10, 10, 11. And we type for item in range of the length of our third list, our third list item equals our third list item times 1000. And we print our third list to check that the list was created correctly. So let's run this code. And as you can see, our third list was recreated. And now we'll create a user-defined function to calculate a mean from a list of integers or floats, and to return the calculated mean or average of the list as a float. So we will make our function definition and give the function a name, which we'll call calcmean, and we will give it a list as an argument, which we must send to the function in order to get our return after the calculations, which we will define. So we type define calcmean list equals a list, and we type sum equals 0.0, and here we define sum to be a float with the value 0.0, and we type for item in range of the length of our list sum equals sum plus list item. And we calculate our mean to be equal to the sum divided by the length of the list. And we return our mean. We can use this function like this. Our mean equals calcmean from our third list. And we print our mean like this. So this function, which we defined with the name calcmean, which is blue, and has a list as an argument within the parentheses, first defines a float, which we call sum. And for every item in the list which we send into this function as an argument, we change this float to be equal to itself plus the value of the list item. And we calculate our mean as the sum of all items in the list divided by the length of the list. And we return this, our mean result, a float. So what we do here is that we create a float which is defined by the return of this calcmean function, and we print our mean. So let's run this code. And here we can see that the mean is 6,928.57 and so on. So now we have shown how to create a user-defined function, and as you can see, it is quite easy to do so. However, when we are doing machine learning and data science, we will not always have absolute control as we have over our own data and code. For example, in this example here, we know for certain that every item in the list is an integer, and we know exactly that the list has values, and we have an absolute control over both the code and the list and its components and values. In machine learning in particular, but also sometimes in data science, this may not always be the case. For example, we have code on data which we don't have perfect control over, or sometimes even little control over. And there are things which could happen. For example, that you could get different objects in the list. So you could have string objects in the list, and you could get a lot of things in the list. For example, you could have a list which is not a list at all, but defined as a list. And you can have a list which is a so-called non-object and not useful. So we must be able to acquire some control over the list and its contents. And we will show one way to create more control in this little extra program with the defined function with a small number of such controls. So this example will not contain all possible or necessary control types for every problem, but a few. And to exemplify this, we will make another function and call it calcmean2. And just as earlier, we will have a list as an argument. So we will type define calcmean2, and we have a list as an argument. And we will enter the first control if list is none. And our solution is to put our mean2 to be 0 in this case. So the first thing we do is to check if the list object is a non-object or not. And else we continue to calculate our function. So we type sum equals 0.0, And if the length of the list equals 0, we set our mean 2 to be 0.0. Else, we calculate our mean for item in range of the length of our list. Sum equals sum plus list item. And our mean 2 equals sum divided by the length of the list. And we return our mean 2. And we can now use this function much more safely. So what this function does is that the first catches non-object and the second one catches lists which are empty and don't have a length. So they don't have any objects at all. And a third check which we could include is, for example, if the list would have a length, but the objects inside it would be empty or non-objects, which could, for example, create a division problem exception when the division executes in our function. So that could be an interesting exercise for a student. Now we'll type our mean 2 equals calc mean 2, and we will send it our third list, and we'll print our mean 2. And we will run this code, and we received the same mean or average. So, and this extra code results in that we can use this code with that little bit more safety and run this code with our third list as an argument. And these extra control checks which we have entered in the code means that we can use this code with a little bit more safety and protections. So now we'll take a look at the generalization of the functions and connect this video lecture to the earlier video lectures about collections, lists, and dictionaries. So in these functions, we will have no protections for the execution of the program because we will show this generalization and how to use functions more practically. So we start to type. Let's make a more general function and count the number of unique items in a one-dimensional list or other list similar connection. So we type define count unique items We give it a collection. And we begin to create a return dictionary, which we call descriptive stats. And we define it as empty. This is a dictionary and the return item. And we type for item in collection. If item in descriptive stats item plus equals 1. Else descriptive stats item equals 1. And we return descriptive stats. So what this function does is that it takes any iterable collection as an argument, and it begins by initializing a return item, which is a dictionary in this case, and for every item in the collection, if the item already exists inside the collection, an item could, for example, be an integer in this case. If that item already exists in our dictionary, we just add 1 to the value of the item. And if the item does not exist inside the dictionary, we add the item. And at the first initialization of the item key, we add 1 as the value. And finally, when we have counted all the items in our collection, we return the dictionary filled with the counts of all unique items. And we can use this function in many ways. We can call it as part of another function without explicitly naming or referencing the return object. So we type print count unique items, and we send it our third list. And we run this code. And here we can see that we have 3000 two values, 4001 value, 5001 value, 6000 two values, and so on. And we can name the return object, print, and sort and print the output of the function. So we type descriptive statistics2 equals count unique items, our third list. And we type for word in sorted descriptive statistics2 key equals descriptive statistics2 dot get. print descriptive statistics to Word. And Word. And we run this code. And here we got the list sorted on the value of the number of counts of each unique item. So here we can see that we had one with 4,000, one with 5,000, then we have two, 3,000. And we can see that it corresponds to the earlier list. And we know that this is a correctly constructed dictionary of the counts of unique values. So we can make an even more general function able to handle uneven multi-type 2D list of lists. And we can show how functions are able to reuse code and lessen the number of lines of code necessary for a program. And we can create a special 2D uneven multi-type list of lists. So we type our special list equals 139. We have 3 items in the first list. We put a float, a 3, a 9, a 9, 4 objects in the second list. And it's a float, integer, and string. And we can put 5 items in the final third list. So here we have uneven lists. They have different lengths, but they all are placed in the same special list. And these uneven lists has objects of many types. So we can print our special list and we run this code. And here we can see our lists. So we have one list with 3 items, one list with 4 items, and one list with 5 items. And the first thing we will do is that we will create a standard function for adding dictionaries together. So we type define add dictionary A and dictionary B. And we type dict equals key dictionary A get key 0 plus dictionary B get key 0. For key in set dictionary A set dictionary B, and we return a dictionary. So what this function does is that it adds two dictionaries together wherever the keys connect to each other. And this is a very useful function. And now we'll show how it works. So we type create a function creating dictionaries and adding them together with our add function. Create a function for creating dictionaries, the list or collection, and use our add function to add them together. So we type count unique items to collection, and we have a dictionary of unique items. And it is a dictionary and a return item. And we type for item in collection dict item equals count unique item items, and dictionary unique items equals add dictionary of unique items and dictionary item, and we return our dictionary of unique items. So here we have three very interesting functions, but you can only see two functions right now. So first we have the support function, which adds two dictionaries together based on the set functions on the keys, and returns a dictionary with these dictionaries added together. And the second function we have is a count unique items too. And you can send almost any type of collection into it. If it is, for example, a list of lists. And it will use our earlier count unique function to count every list or collection item which is sent to the function inside the first list and add all these items together and return them as a conjoint dictionary counting all unique types inside this list of lists with these three lists of an even type and with many different objects inside the lists. So now we'll use these functions. We type descriptive stats equals count unique items 2, and we can send it our special list, and we type for word in sorted the script stats key equals script stats dot get print the script stats word and word. And we will fix some small things. Items, item, the parentheses. So let's run this code. And here we can see that we have one float number. We have one string 6. We have two ones. We have two 4s. We have three 3s. And we have three 9 strings. And as you can see, this is very useful to know. So now you have learned how to create your own user-defined functions, and you have learned how to create some safety barriers for the execution of your code. And for example, you have learned to protect yourself against empty objects, against non-objects, and against some anomalies that may create exceptions and similar problems, and which could crash programs for a particular function, such as the division function, for example. So you have learned how to create functions by using materials from earlier video lectures, and you have learned how to generalize functions to arbitrary object types and advanced list constructions. So now it is time to congratulate you for having learned to create your own functions. And this is very useful and very powerful knowledge. And we look forward to see you in the next video. Hello and welcome to this video about Python for data handling. We're excited to have you here, and in this video you will learn some theory about Python object-oriented programming. And we will concentrate on the parts most relevant for data handling. Objects and classes are one of the most important parts of the Python language and a major component of object-oriented programming, or OOP. Class definitions enable you to create Python objects or custom Python objects. In the Python language, every Python-defined entity is intended to be an object. Python data types and storage containers are all objects. Integers, floats, strings, sets, tuples, dictionaries, and lists are all objects. The Python objects are containers for data and include methods used to access or change data inside the containers. Objects as containers for data and enablers to change or not to change that data are therefore of central importance to data handling with Python. So what is object-oriented programming, or OOP? Object-oriented programming is a programming model based and focused on the concept of objects. Objects containing data and code and sending messages to each other. These objects are the tools used by the programmer to achieve the goals of the program. The object orientation programming model creates many benefits, such as a flexible ability to model or divide code, or to divide coding work into parts. Object-oriented programs are considered to be reusable, scalable, and efficient. Object-oriented programming uses classes to define objects. A class is a type of blueprint or description for objects belonging to the class, and describes how individual objects are defined, with members such as data, which is called attributes, and functions, which is called methods, when they are inside an object, and an object as a modeling entity can correspond to a real-world physical object or an arbitrary abstract entity, sometimes only known to the programmer. Now we are going to talk about object-oriented concepts. A created object belonging to a class is called an instance of the class. A class may have a finite or any finite number of instances of itself, all with different values of data objects inside the object. Classes can contain many different data types and hold a number of functions which are called methods when contained in a class or object of a class. So we can say that a class has methods and data objects. And the concept of a class or object holding data is usually called encapsulation. And the word encapsulation is taken to imply that the data is protected from being contaminated by neighboring data values, for example overwritten or similar things. So this encapsulation is a type of protection for the data values inside the object in the class. And classes can be derived from other classes, and this is usually called inheritance and means that a new class can be one or more already existing classes. So we can say that a new class is of another already existing class. But these inheriting classes may have changed class mechanics. And some programmers view this as a type of copying, so you are reusing an object and changing it a little, and they call this efficient. and other programmers see this inheritance as something you are using as a modeling features. So for example, you may have a class of animals, and you can inherit and create many new different types of animals. So you can have dog animals, you can have cat animals, and they are all animals and have the animal class's feature, but they inherit and change parts of the class depending on which type of animal which you have inherited from the animal class. So, classes derived from another class may have different methods than those in the base class, and we call this feature polymorphism of the classes. Classes may also contain many different versions of the same methods, but with different arguments. And this feature is called the class polymorphism. Classes may contain other classes. For example, a class may have a data object encapsulated inside the class. And these data objects may, for example, be integer objects or custom objects, lists, or they could be many combinations of objects. There are no limits to how many objects you can hierarchically place inside a class, for example. And in many object-oriented structures, these hierarchies between objects can often be quite complex. An object is created by a constructor method and may be destroyed by a destructor method. And Python also has an automatic cleanup function which uses a destructor method to clean up objects that are not going to be used by the code anymore. And objects in Python are also by default standards different and more object-oriented than in many other popular programming languages. And a few examples of these differences are that in Python everything is intended to be an object, and the degree of object orientation is desired to be 100%. And this means that everything is an object, even the classes are objects, and the instances of classes are objects, and class objects are also objects. In Python, everything is public as a default standard, and this means that objects and their content members are accessible from anywhere inside or outside the class or object as a standard. And native Python supports 3 types of access modifiers, and these are the standard public modifier, the private modifier, and the protected modifier. And in Python, a private modifier means that the object's members can only be accessed within the object class and not from the outside or another class. And the protected modifier extends the private modifier to objects which inherits from the private or protected class methods. So what is the object's importance in data handling processes? In data handling processes, the data, values, data structure, results, models, and data quality are of importance to the data handler, regardless if the data handler is a data scientist, machine learner, AI, employee, programmer, extract, transform, load developer or technician, an engineer, an architect, or other end users such as analysts, economists, statisticians, mathematicians, or researchers. And this means that what is important for data handling is quite different from the ordinary programmer perspective and discussions on the properties of programming languages and the correct, optimal, robust, or reliable way to use these properties in the most advanced, simple, senior, junior, intermediate, Pythonic, or non-Pythonic way. Sometimes these different properties of importance and the evolution of constructs may be at odds or competitive with each other. For example, over decades, a data construct such as a database may evolve through many technologies, data storage standards, taxonomies, and event-modeled structures, or contain such data from different standards used by different companies, municipalities, counties, states, governments, and governance systems. In practice, such systems often evolve from traditional tabular Excel spreadsheet databases spread over many database tables into object-oriented, varying hierarchical structures, which may be very unfriendly in various ways to standard query language queries and tabular data analysis systems. As a direct consequence of the evolution of structures, technologies, and the mixing of different data from many sources, the requirements for skills in data handling and object-oriented data handling is ever increasing. This video course is affected by these facts and will be about learning adaptable skills rather than teaching you to use a few standardized templates mostly useful for tabular databases. We will concentrate on classes, members, data and functions and methods, the serialization of objects for storage, how to load and save objects and similar data handling tasks. The main intention is to teach you Python native object-oriented data handling skills that will make you able to move your data from a structure or file to your control within native Python to make you able to use your data as a data scientist, analyst, or machine learner. So, in this first video, you have learned some theory about Python's object-oriented programming for data handling. In the second video, you will learn to code object-oriented programming with Python with the intention of learning you to handle object-oriented code and custom objects within the ambit of data handling. In the third video, you will learn more about saving files in Python and the practical process of converting custom Python objects to tabular form and saving files into CSV and Excel formats, as well as loading such files to Pandas data frames. And we look forward to see you in the next video. Hello and welcome to this video about Python for data handling. We're excited to have you here, and in this video you will learn to code object-oriented programming with Python with the intention of learning you to handle Python object-oriented code and Python custom objects within the ambit of data handling. So let's start our code editors because we are going to type some code. Alright, having started our YouTube Labs notebooks, it is time to write some object-oriented code. And we will begin to import the pickle library, which we will use to serialize our object-oriented program constructions and save them to a binary file as the final action of this video lecture. So we type libraries, import pickle, and remember the male cat example from the dictionary. Video lecture. We will reuse the male cat. We type class male cat object and we define it as init self id name mail address and list items. And this function creates an instance of the class. So in practice, this is the constructor of this class. And we type self idnum int. And we will use this as an id number in terms of identifying this object among all other objects of this class. The identity name, which will be set equals to id name. And it will be the name of the record in our mail catalog. And we will have a self mail address, which will be equal to the mail address mail data. And we will have a self list items, which will be equal to list items. And this is a list of arbitrary data items or objects. And we will define a number of methods. So we will type define get identity name of yourself. These methods to create methods in objects. So here we will return self identity name returns a string. So if we call this method, the object will return its identity name. And we can type define get mail address. And it will return the string which corresponds to the mail address. And we will have a get list items. Which will return a list of arbitrary objects or items. So we return self list items. So here we have the definition of every object in the mail catalog. So we have data values and we have methods or functions. And now we will create a class which we will call mail cat collection with a dictionary using identity number as key. So we type class mail cat collection and we define init self and upon its initialization or instantiation it will create a dictionary with identity number as key and mail cat objects as values. So we type self index counter equals 0, and this is the first key number. And we define add mail catalog object self mail catalog object. So here we create a method which creates objects for this dictionary. So we type self index counter plus equals 1. And this creates the next identity number to be used with the dictionary. So here we create the key which we will use for the object which we will create and put into our dictionary. So we type mail cat collection id number equals self index, which is the key number. And we type self mailcat.update mailcat collection dot identity number and the mailcat object. And this line updates the dictionary with a key and value. So now we will create a class which encapsulates our mail catalog, adds 4 start entries into the mailcat collection object. Named data. And the class will have 2 functions for printing and flattening the object's data. So we type class create catalog, and we type define init self. And the self dot data equals our mailcat collection. So we type self data add mailcat object Joe at gmail.com. And we give him a list 1200 99.3 0 float 0 value completion percent. And we type self data. And here we can simply copy this line and we type anand dot anand at americanonline.com, and we give him a set of numbers and a set of strings. And answer %. And we close that command. And we create the next object, which is Lisa. gmx.com. We give her some numbers. Value and completion %. And we have Muhammad. Muhammad@gmail.com. And he has the value 1700, 82.3. And value and completion %. Like this. Now we'll create a function which will print all these objects to screen. So we type list mailcat objects self, and we type dictionary equals self.data.mailcat. And for key in dictionary, mail equals dictionary dot key, and here we get the object instance and print the relevant data values and objects. So we type print mail id name mail.mail address and mail.list items. And we define another function which serializes our objects in the mailcat collection. So we type serialize mailcat and dictionary equals self.data.mailcat. And we create a return list and we create a header string which we have a name in. We have a mail address. We have a integer 1. We have a float 1. We have a integer 2. A float 2. A string 1. A string 2. A string 3. And a string 4. So this is our header string. And the first thing we'll do is that we take the return list and append our header. And we type for key in dictionary mail equals dictionary key. And here we deliver the object instance to our function and print relevant data values and objects. We type list string equals join string item for item in mail.list items. And we type mail string equals string mail id name plus string mail address plus string. And we append our mail string dot split. And we return return list. So what we now have is a object which we use as a program function, which creates and encapsulates our mailcat collection, creates 4 mailcat objects instances, and adds to our dictionary inside this create catalog class object instance. And inside this object instance, we have 2 functions, one for writing all the content of our dictionary with mail catalog objects to our screen, and one which serializes the data in these objects for use in analysis or to save with certain files. This means that we now have shown a simple and easy and common object-oriented textbook way of treating data with encapsulation. And I've also included a double hierarchy of objects, methods, and the 2D data objects, or list of data, which is the second hierarchical data dimension. And this is a quite complex data object to handle in reality, but is also a very simple structure to show how these objects can interact with each other. Because in complex object-oriented hierarchical databases, you can often have objects which are intertwined, connected to each other, and often contains each other in lists of lists and many other constructions, which can make the data structure very complex to handle and hard to move to a serializable and tabular form, which we want to use for our analysis in most cases. The catalog, and show how to make the catalog object serializable for file storage and analyzable with standard. Programs and libraries expecting tabular or column data. Let's type mail C equals create catalog, and we type mail C dot list mailcat like this. So let's run this code. And here we can see the objects printed to screen. So we have Joe, we have Anand, we have Lisa, and we have Mohammed. And now we're going to use the pickle module, and the pickle module implements binary protocols, serializing and deserializing Python object structures. And we can say that pickling is the process of converting a Python object hierarchy to a byte stream, and unpickling is the inverse process of converting a byte stream back into a object hierarchy. Pickling and unpickling are also called serialization or flattening of files. And the opposite is deserialization or the flattening. So now we're going to use Python's pickle module to serialize or flatten this object structure to save it to a binary file. And after creating and saving the file, we will delete our mailc object and recreate it from the file. So we type file equals open mail c object write byte, and we type pickle dot dump mail c and file, and we close the file, and we delete mail c So the first line of this code opens a new file, which we have named mailc object, with a write byte stream, and we uses pickle to dump mailc to our file. And this serializes the mailc object with all its included objects and saves it to a file. And we closes the file and we delete the mailc object. So let's run this code. And now we will print the mailc object. And this will trigger an error because mailc does no longer exist. So now we'll recreate mailc. So we type file equals open mailc object, read byte, and we type mailc equals pickle, and we load the file. And we close the file. And we test that the mailc object is recreated by printing the objects to screen using its function. So let's run this code. And as you can see, our object has been recreated with its entire structure, data, and methods. So now we have shown you one way to permanently store Python objects, and we have given you a thorough first taste of object-oriented methods in Python. And in the next video, we will take a deeper look at common file formats, CSV files, Excel files, and Pandas files. All for the purpose of data handling and to get to this tabular structure, which is so important to be able to use object-oriented data structures for data analysis, data science, or machine learning. And we look forward to see you in the next video. Hello and welcome to this video about Python for data handling. We're excited to have you here, and in this video you will learn about saving files in Python and the practical process of converting custom Python objects to tabular form and saving files into a CSV and Excel formats, as well as loading such files to a Pandas data frame. This is one of the main purposes of data handling and enables the execution of proper data science and machine learning with many standard libraries and tools. So let's start our code editors because we're going to type some code. All right, having started our Jupyter notebooks, we must begin by defining the objects which we will use in this program. And we will use the objects from our last video lecture. So we will have the mailcat objects, we will have the mailcat collection, and we will have the create catalog class, all defined and to be run. So we will run these classes to initialize them into our program, like this. And the first thing we will do is that we will import libraries. And the libraries we will use for this video lecture is the pickle library, which we know from earlier video lectures and which we will use to load our stored objects. And we'll use the CSV library, which is about comma-separated files, and we will use the OpenPy Excel, which is about Excel workbooks. And we will use the Pandas, which is the mighty Pandas library, one of the most useful and powerful platforms for data science available. So we begin to type libraries, and we type import CSV, import pickle, import pandas as PD, and from OpenPy Excel, we import workbook. And we begin by loading our mail catalog from our pickle file. So we type file equals open mail object and read byte stream. Pickle, and we use pickle to load our file. And we close our file. And to check that our object has been restored, we type .list mail catalog objects, and we run this code. And as we can see, our objects has been restored. Having restored our mail catalog from a file, we should take a look at common file formats such as the comma-separated files and Excel files. And the tabular form will often be desirable for data handling purposes because most Python programs and libraries are adapted to it. And that is around 99.99% of all code you will ever run unless you work at a company which uses specially adapted code and repurposes the code for special data structures. So the comma-separated file, or if unsuitable, another separator, is a stable foundation for conversions between formats and programs. So let's begin by flattening our objects into strings on the tabular form and create a CSV file, which is a comma-separated file. And this is a very old standard which has been used since the advent of personal computer computing. And in principle, every program is able to somehow use comma-separated files in various dialects. So this is a file format which everyone can use, with the caveat that there are many dialects of the comma-separated file. So what we will do now is that we will use our second function, the serialize mailcat objects function. So we type mail C2 equals mail C dot serialize mailcat objects and we print mail C2 to screen. And for item in mail C2, we print item. And the reason that we does this print to screen first is to check that our function has been properly written because we didn't check this code in our earlier example. But now we will run the code. So let's run this code. And here we can see that we have the header first. The string. So what we can see here is that we have a list of lists in the first here, and that every object has been serialized into a list of strings. And this appears to have been executed flawlessly. And to make this a bit clearer, we have listed every of these lists of strings inside the list on their own row. And one intriguing feature with this particular construction is that we have a 10 variable file, but 3 of our 4 rows, 4 non-header rows, have only 8 variable observations. And this is a very common trouble with some computer programs. But we will show the power of Pandas in this program and how to handle this particular feature in our code. So, the first thing we will do is that we will create a CSV file, and we will begin by opening a CSV file in write mode. So we type with open mail cat.csv, write mode or double view, and new line equals standard dialect. And we open this file as a CSV file. And the next thing we will do is that we will use CSV writer object to write the list to the CSV file. So we type writer equals csv.writer CSV file. And we type writer.write rows mail C2. And use write row for a list of single strings and write rows for list of lists. The file closes after finishing the with code block. And we can say that this CSV file has a tabular form and is useful for direct use with most libraries and programs. So, This code shows how to convert this CSV file to an Excel workbook and how to load the CSV file into a Pandas data frame. So let's begin with Excel, which is the main data storage standard for everyday home or business data with an estimated 100 to 500 million unique users. That's something to think about. This is likely the biggest data storage program and format for everyday data. And as such, it cannot escape being treated in a course which is called data handling. So we begin by creating a temporary storage file for our CSV data. Temporary storage. And we begin to type with open, mail, catalog.csv, read, new line equals standard, a CSV file, reader equals CSV reader, CSV file, and for row in reader, CSV temporary append the row. And we will create a workbook. We type workbook equals workbook. Create a new workbook. And sheet equals workbook.active. And this sets the sheet as active sheet in the workbook. And we type for row in CSV temp sheet append row. And we use a function to save our workbook as mail cat XLSX. So let's run this code. And the first line of code opened up and created a CSV file. And we wrote our serialized object, this object, to the CSV file using the write-rows method. And the second thing we did was that we opened our CSV file and we created a temporary reading from the entire file. And we stored the temporary reading in a Excel workbook file. So now we will print the Excel document file using the open by Excel library. So we type for row in sheet, iter, rows, row list equals an empty list. And for cell in row list and string cell value plus an empty space. And we print row list. And this code creates a specialized for loop on our workbook sheet, which we have called sheet. So it uses the iterRows function to create a for loop over the spreadsheet. And we create an empty list, and for every cell in a row, which is a Excel row, we will append every value which it finds in a cell, and we will cast it as a string, and we will add an empty space behind the object. And we will print every row in the Excel file. So let's run this code. And here we can see that we have a perfect Excel file with 10 variable headers, followed by 8 variables, including missing values, followed by 10 values, including now missing values. And we can load our CSV file into a Pandas data frame for use with Pandas. And Pandas is a Python library with a very large user base, estimated at 5 to 10 million users. And Pandas is considered to be an Excel spreadsheet with extended capabilities for data science and all types of machine learning. So Pandas, it is a great and useful library which you should learn. It is also extremely powerful. And we will show some of its power now. So we will type mailcat data frame equals pd read CSV mail cat.csv delimiter is the comma. And we print our mail cat data frame to our screens. So let's run this code. And here you can see that we got a data frame print with, in principle, one line of code. And as you can see, Pandas is an extremely powerful piece of software with highly useful components, and it's also extremely fast. And it can do a lot of advanced work on complex and also huge-sized data without writing too many lines of code. So Pandas is excellent for large scales and computationally demanding tasks. And Pandas is also an excellent platform for data handling operations and conversions into, for example, NumPy arrays or similar data items. So the combination of Python and Pandas is, I would say, with 20 years of experience, the optimal mix to handle data handling and all types of data science and machine learning tasks. So, all right. In this part of the video course, you have learned deep knowledge about object-oriented Python programming for data handling tasks, and you have learned how to technically execute these data handling tasks using Python with some libraries. So what you have learned in this part of the video course, and with the support of the other video lectures in this part of the video course, is to execute the technical part of the data handling process. Using the code and the knowledge which you have learned in this video lecture, you are now able to technically execute most types of the data handling tasks, and you should be proud of yourself for finishing this video lecture. The concepts in this video course corresponds to the first years of studies in computer engineering at the university level, and combined with the more complex structures of data handling, you are training to obtain knowledge at the master and research level. In the next video, we will make a recap and we will extend the knowledge about files and data handling. And we look forward to see you in the next video. Hello and welcome to this video about Python for data handling. We're excited to have you here, And in this video you will learn some about loading text files in Python and the practical process of advanced data handling, which is to convert data to usable data structures, to construct calculated variables for analysis, and how to use these datasets of Python native constructions with libraries and already learned object-oriented code from earlier video lectures. So in this video we will do a recap of already learned knowledge and we will extend the knowledge. So we will take a look at loading data from text files and how to develop loaded data into tabular analyzable form. We will do this by using already learned knowledge from earlier video lectures and assemble these parts of knowledge into useful knowledge in this recap. So we will show you how to use the created tabular analyzable form with the Python library Matplotlib and how to create an advanced graphical structure using Matplotlib. And most other Python libraries are also used in the same way, so you can use the same model to access libraries such as scikit-learn, stats models, and other libraries. And we will also show you how this tabular form and individual data from the table can be incorporated in our earlier object-oriented programs to give you a wider overview of how data handling fits with advanced object-oriented program structures. So let's start our code editors because we're going to type some code. All right, having started our Jupyter Labs notebooks, we will start to type some code. And the first thing we have here is that we have some code already placed in our Jupyter Labs notebook. And this code is downloadable from the course page, or you can simply download the text file .text from the course page, which this code will create for you when it is run. So this code will create a dictionary of lists where the lists have names as keys and lists as values. We call this our variable dictionary. And this dictionary contains the data which we will use in this video course. So we create a file with a file header from the variable dictionary. And we create the text file. And we write this header to the text file. And as a data handling abstraction, this header contains the names of the variables or columns for our data. And the second thing we will do is that we will turn our dictionary of lists into a list of lists and transpose it to a list of lists. What we will do is that we will take our dictionary of variables, we will turn it into a values part, and we will convert it into a list of lists. And we will turn this list of lists into variable format. So what we have is that we have several data observations with data values in list. So we, for example, have observations with, say, 5 data values. So what we will do with this transformation is that we will make the variable the subject of the data file rather than the individual observation. So we will turn the data file into a more useful format. And we will print the list and the transposed lists to show you this feature of this code. And finally, we will open the created text file and we'll print our data values to the text file. And this \n, which we add to every string in this file, or every string which we write to this file, is a new line, which tells the text file that it shall look for a new line, or rather the next line in the file. So let's run this code. And here we can first see the header of our file, which is the birth date, experiment start date, experiment end date, weight at the start date, and weight at the end date of this experiment. And first we have some prints of a list of lists. And here we can see that we have birth dates in the first list of lists, and we have experiment start dates in the second lists. And we will run our transposition. And what happens when we have transposed this file is that we have a birth date followed by the experiment start date, followed by the experiment end date. Here we can see that we have transposed this matrix of variables and observations. And this is a very useful code to know and understand when you work with tables. And finally, we have a printout of the data values of our file. So now we'll start our video lecture. So after running this code, or after downloading the file from the course page, we have the file in our active directory. And this means that we don't need this code anymore. So we can simply mark here and we can delete it. Like this. And now we'll start with the video lecture's practical code. So we begin to type import datetime module as dt and matplotlib.py plot as plot. We type import datetime as dt. We import matplotlib.py plot as plot. And we will read a text file into a read datas list of strings. And the file can be downloaded from the course page or be created with a downloadable Py file. And this read text file code can be adapted to almost any type of text-based data file. So it is very easy to generalize the code we are going to write now. And the Py file is interesting to study because of its advanced data handling code. So remember to take a good look at the code which created this data file. And now we will type read datas equals an empty list, read counter equals 0, an empty integer, which we will use to keep track on the number of lines which we have read from our text file. And we type with open text file.text as an input file. We can type for read data in input file, read datas append read data, and read counter plus equals 1. And we can type input file close. When we have read all we want from this text file which we have opened, we also close the file. And we will print the read counter, and this will print the number of read lines or code from the file test. And this integer also shows the number of read lines, which is interesting for some calculations. And we can print read datas, the first line, which is printing the header with the variable names. And we can print read datas. So we will print the entire list of strings. So let's run this code. And here we can see first the number of read lines, and these are 5. We are printing the header, which is birth date, experiment start date, experiment end date, weight at the start date, and weight at the end date. And we also print our entire list of strings in read datas. And here we can see that our list of strings has been properly read from the file. All right, now we will use a function to split our list of strings into lists. And we will split on white space. If you can see the printout of the data, we have white space between every variable. And in this case, only one single white space. Because we designed the file, we know that it is only one white space between every variable. Let's type define split data, and we take a list as an argument, and we create a number of lists. The first is a header, birth date, experiment start date, experiment end date, weight at the start date, and weight at the end date. And for the new lines, we need a list. And we type for data in read datas, if read datas dot index data equals 0. And this is special treatment for the header. Header equals data.split on the white space. And we delete header -1. And this will delete the new line at the last position of the header list. Else, words equals data.split and we type birth date, append, words 0. And we continue. And we can make this very much quicker by copying some. Like that. And finally, we will delete the new line because the new line is a feature of the text file. And it is used in the text file to structure data. And we don't need it in this program. So we will type return header bd esd eed vsd and ved. And we will use our function to create a list of headers and 5 lists of red variables. In list, we type header, birth date, a start date, a end date, wait at start date, and wait at end date equals split data on read datas. And we will print the variables to check that everything executed properly. We type print birth date, print wait at end date, and we can print the header. So let's run this code. And here we can see birth dates. We can see weights at the end of the experiment. And we can see the header with birth date, experiment start date, experiment end date, and so on. So now we know that we executed this code correctly. So now we will convert the data to usable formats. And we will know that header is string data, birth date should be converted to datetime, start date and end date are strings directly compatible with datetime. We start date and we wait at the end date are strings directly convertible to integer format. So we will create datetime objects from strings and convert strings to integers. And we will do this with a for loop. So we type for date in range of the length of the birth date, and we type birth date date equals datetime datetime strip time. Birth date date. And here we will use a particular string format. We will type percent large Y slash percent small m slash percent small day. So this format will read these strings and convert it to a datetime format and replace the string in the birth date with a datetime with a similar value. And we will convert experiment start date date using the same command. But with a different type of strip time, where we will type %y line percent month line percent day. And we will use the same code to convert the end time, which has the same format. And we have the weight at the start date, which we will cast as an int. Like this. And we have the weight at the end date, which we will cast as a integer. Like this. And we will print birth date of 0. And this is an interesting feature of datetime objects and lists. And here we must say that we will put up a big warning to use these datetimes with lists. And you will see why very soon. So we'll print the end date, which is a datetime object, a list with datetime objects. And we will print the weight at the end date, which is a list of integers. So let's run this code. And here you can see a interesting feature of the datetime object when it is inside a list and when you call it from outside a list on, for example, a positional basis. Because when you type datetime objects inside the list, or perhaps executes a serial computation on a list of datetime objects, the datetime object will look like this. Whereas if you address it in this fashion, it will look like this. And this difference is interesting, and it is one of these things that sometimes can make aircrafts fall to the ground. Because this is very subtle and you won't discover it until you check the realism or the difference between different calculations. And one stealthy feature of this, you could say feature of the datetime object and the list is that it is very stealthy. So you can't see this thing happening until you use two different calculations on the objects and compare the output of them, or use both types of way of looking at the datetime object with the same calculations, because then the results of the calculations will vary very widely depending on how you interpret the datetime object and what function that does it. This is something that is very important to keep in mind when you're working with datetime objects. And some people, they think that datetime objects, they may be so fishy or out of control that they often use datetime object to calculate differences in time. But when we will use the datetime object or the date for some calculations, they convert the datetime object with their own function into a different time scale. And this is very important to keep in mind and to have control of all such functions when you work with objects. And in particular, objects that other people code and have control over. Now we will calculate more variables with practical use. We will calculate the experiment duration in days. We will make it an empty list. We will calculate the age at the experiment end in years. We will create a zero list with zeros. And this zero list is very useful combined with, for example, the duration of days lists. Then you can say that all experiments start on day 0 and they end at a later numeric time or day. And we will create a list of labels for each participant in our experiment. So now we will create all of these lists. We type for date in the range of the length of birth date. We type duration in days dot append end date dot date. The experiment end date minus the experiment start date dot date. And we convert the result into days using the datetime object's days function. And we type age at experiment in days equals days dot date minus the birth date dot date. And this is a variable which we create in the execution of the loop. So this is a datetime object which we will, a datetime delta object which we will write over time after time. We type age at experiment dot years equals dot append age at experiment days floor divided by 365. And we type 0 list append the integer 0 and e-labels dot append e plus string date plus 1. And we will print duration days. We will print age at experiment years, and we will print the labels. What this code does is that the first line in the loop creates the duration of the experiments. The second line creates, or rather calculates, the number of days old that each experiment's participant is at the day the experiment ends. And the third line calculates the age of years of the participant at the day which the experiment ended. And the zero list just fills an list of zeros, 1 0 for each experiment. And the labels of the experiments are created with an E for experiment and the date plus 1. So the first data object will receive E1, the second E2, and so on. Must add some days there. Let's run this code. And here we can see that we have the duration in days first, and we have the age of the participants in the experiment at the last day of the experiment, and we have the labels of the participants in the experiment or the experiment. So we have a list header with a variable containing the names of the days variables, and we have a dataset of 5 lists with base variables named birth date, experiment start date, experiment end date, weight at the start date, and weight at the end date. We have 4 lists with calculated or created variables. In total, we have 10 lists, and 9 of these lists can be said to form a virtual spreadsheet or columns linked to each other through the order of the data elements in the lists. And reaching this stage is one of the main goals of data handling. From here, you can use most, if not all, Python libraries. And to show this, we will graph some of our variables using Matplotlib. We will show you how to use the spreadsheet you could say virtual spreadsheet with Matplotlib. We will create a graph from the created or calculated variables or virtual spreadsheet table. Data. And we will begin by creating two scatter plots. We type figure x equals plot subplots. So here we tell Matplotlib to create a figure object, an x object, and to be ready to create subplots. And we type x scatterplot, and we give it the zero list, and we give it the start date weight. Color green. What we give it here is two lists, one with zeros and one with weights at the start date. And we create another scatter plot, and we give it the duration of the experiment in days, and we give it the weight at the end date. And we set the color of these observations to blue by using B. And we will plot the development over time. We type for M in the range of the length of the zero list. We type x1 equals zero list M, y1 equals weight at start date M, x2 equals experiment duration days, and y2 equals weight at the end date. And we plot the development over time as x2, x1, and y2 and y1. And we color the development in red. And we will label the data points to make the development more visible. We type for n and dates in enumerate labels x.text 0 list n wait start date n dates, and we set the color to green. So here we label all the observations at the start date of the experiment. And we type x.text duration in days. And we use the wait at the end date, dates, and the color we set to blue. So this code will put labels on the data points in the graph, which we will create. And we will add titles, labels, and legends to make the graph easy to understand. And trust me, this is a quite complex graph, so you will need some extra help to understand it, explain, and clarify graphs. We type plot title, Matplotlib multi-scatterplot of test data. Add that we also have a multi-line plot inside. This is an extremely advanced graph with almost 10 plots on top of each other. We type plot x label, test duration in days, and we plot the y label as test weight in pounds. And we can add a legend. We type before test, after test, post test. and difference. And we can show the graph. We type plot show. So let's run the code. And here we can see that we have a Matplotlib multi-scatter plot, multi-line plot of the test data. Where we can see that we first have made a scatter plot of these points, and we have added a scatter plot here of these points, and we added the difference as lines between the position at the start of the experiment and the position at the end of the experiment. We printed a line between these points. And we put labels on these data points here at the start of the experiment and at the end of the experiment. We added X labels, test in duration of days. So here we can see that experiment 3 had a duration of above 190 days. And so on. And we can see the test subject's weight in pounds at the start of the experiment and at the end of the experiment. And we created a legend which explains that the green is before the test, the blue is post-test, or perhaps we should have printed experiments, and the red lines describes the difference between before the test and post the test. All right, this is a complex graph utilizing complex coding on a small sized dataset. And when you understand this code, you have reached the master or research level of computer code engineering at most universities in Europe. Congratulations, because you deserve it. Now we will connect this knowledge to our earlier object-oriented video lectures. And we will cut and paste some code. Like this. And we will not run this code, but we will say that you can remember the Mailcat object class from the video lectures about dictionaries and object-oriented programming. And one way we will connect the code which we have typed in this video lecture with the code from the earlier video lectures is that the OOP classes which we used to create and store data in our object-based dictionaries can be easily connected to the code which we have written now. For example, every experiment in the graph we have made and the data that we have, every E could either be a mailcat object in the catalog and the data points would enter in the list items, or every experiment could be utilized for several persons, and then the experiment could be entered as a dictionary in the list items. So every experiment which a person participates, it could be every time a person visits a doctor, for example. This type of code could be created to create a very useful registry of all the participations of every individual, which you have, for example, at a medical facility. It could be a medical journal for a person, or it could be a registry over experiments. So as you can see, this code is very, we could say, adaptable to various types of situations. So every experiment could be given a key and all this data which we have created for it in the header and the variables could be entered in a list in this dictionary as a value. And this dictionary could be added as a list item for this particular person, or as a dictionary of dictionaries inside the list items if you want to make sure that the keys to every experiment is unique at the list items level. So now we have reached the master and research level of computer code engineering. We will once again say congratulations. So, in this part of the video course, you have learned about object-oriented Python programming for data handling tasks. And in this video, you have had a recap and an extension of your already learned knowledge about data handling. And now you master Python for data handling. And we congratulate you once again for completing the lectures of this video course, and we look forward to see you in the next video.